of them they cannot come due to like crash with the others events, etc. So they just ask whether or not that it can be recorded. Yeah.
Okay, sure. Yes.
So just let me know if that is like you only permit some people to see it, and then I will just let them know, or you just can open it to everybody. Because it is like,
Sure. Yes. I mean, the idea about sharing and recording is just in case you can't catch what I say. You know, the jitter is very common now in Zoom. You know, the communication networks, so you can always play it back, and you can always you know, ask me for questions. I have prepared about 100 slices.
oh, 100
Okay,
slices.
but most of them are pictures. Most of them are pictures because I have a belief, if I could teach my little daughter and she can understand what I'm saying by pictures, that means anybody could understand. So that's my philosophy.
That's great.
That's my philosophy.
It's so difficult to catch up. I mean, it's like we have got some researchers from like we have got professors from like Australia. We have got some other individuals who may not be that expert in that area. So it would be great. Yeah.
Everyone is expert in some way, in some field.
Yeah.
It's just that I think, as you have mentioned, this purpose, that the purpose of this webinar is to build friendship, is to get to know each other. So we first start with some big pictures about our dream, about what we want to achieve, what we can do together. And I believe that we can always meet up again, maybe other webinars, or even better, if the COVID-19 is over, you know, I can come to you, physical workshop, 3 days, you know, technical details. That would be the time for the technical details.
Right.
Yes. Yeah.
I hope that it will be end. I mean, the COVID will end sooner or later, because it's like, well, all the events that we try to hold it in physical form, it has already returned to like online schedule. So it's just like, but
that's right.
It will be sooner or later.
Yeah, we really hope so. Yeah, we should have a seminar about forecasting and predictions about when COVID-19 will be over.
Oh, really? You have done that already?
Yeah. Get the WHO to fund us.
Okay, so which day that you think will be like over for the prediction? Just one
March next year.
Really? March next year. Oh, okay.
Yeah, it won't be suddenly over, but we will be expanding like bubbles. They're talking about bubbles, like maybe between Guangdong, Hong Kong, Guangdong, Macau. They already formed the bubbles. People between two areas can travel. I don't know when between Hong Kong and Macau, but sooner or later, the two bubbles will merge into a big one, and then it will expand. It will expand to Taiwan, Philippines, and you know, Southeast Asia, and Australia, and then cross the continent to UK, Canada, and US. I think this is what's going to happen.
Hopefully.
We are seeing small bubbles anyway, so there's hope that the bubble will get bigger and bigger.
Hope so. I do hope so, because it's like everything that, like for example, those who that my co-authors that we are working on, that they invite me to go to China, and then I want to invite them to go to Hong Kong as well, same as you. So actually we want to invite you to Hong Kong as well, but then
yes, come to Macau, please.
Sure. I love going to Macau.
Yeah, I love to visit your office, your lab, and your new center. It's amazing. Anyway, we'll talk more about this. If you can start recording, I would start my my PowerPoint right now. Okay. All right. There's a topic here: data stream mining for fast AI. Now, there's basically about two things I want to achieve today. First of all, I want you to be inspired, whether you are a researcher or a researcher going to be a lecturer, or maybe even a students, you know, research students, postdoctoral student, or whoever, who may want to look into the potential projects, research projects. So I'll be showing you basically about some applications from my past years' experience, you know, the trend and the evolutions, and where the so-called machine learning, the AI, this is a little bit alternative anyway. We call it data stream mining. I have a reason for that. You know, we will be seeing a roadmap and the directions and visions on where we are going to. So that is the first objective I like to achieve with everybody. Now, the second objective I want to achieve is I like to clarify about AI. It has a long history, of course, grandfather stuff anyway. Back to 1956, I think by John Carter, in the 56, he coined the term AI, which is the classical theory in simulating about neurons in our neural brain, of course, in the machines. And then here came Alan Turing, the grand challenge about the object recognitions and so on and so on. Until today, we have seen a lot, in fact, too many AI, even on commercial products. Do you agree with me? Let's say you buy a camera, you buy a washing machine, they will tell you that it got AI inside. All right, it got a fuzzy logic inside. But
that would be very fuzzy, I think. In reality.
Precisely. So it sounds cool, and they can mark up at 20% of the price, and it's more suitable for consumer market. But when we come to the research direction, especially I believe that you have a sustainable building research center. I believe the research you are doing is not for, I think, consumer market. It's not just a retail product. These are big projects that involve about safeties, building materials, sustainability, and so forth. So I am just hoping. I mean, I'm a small potato anyway. I'm no big shot.
Oh, no,
I'm not here. No, I'm not here to flip the table about AI and to challenge any big guys who are the the public figures about AI. But I am trying to be down to earth. And through this webinar, I hope that we can see clearly which part of the AI can contribute to the series research projects, and which one are the commercial ones, the marketing gimmicks, and which one are the theoretical ones, which they haven't picked up the momentum. Okay, so let me just quickly move on. Now, my research is quite simple. All the whiles in the past 19 years, I've been just doing two things: data stream mining and optimizations. Now, why is that so? Because data stream mining, roll back to about 19 years ago, I predicted that the data that we have today is not structure records. Structure record means you have instances, you have the attributes, and then you have a label. So IoT, for example, and data streams, all these are distributed data streams which run continuously, and they could be messy. They could be signals. There could be Wi-Fi signals. There could be 5G signals, or there could be computer visions. We can have a what we call the 3C in the the 3V in the big data: variety, velocity, blah blah blah, and so on. Now, before people actually came and tell us we're going to have big data, data science, which is very sexy and hot nowadays, back to 20 years ago, I look forward and I sort of predicted today, this is one of the hot fields, data stream mining. So this is why I've been doing it for so many years. The other one is optimizations. I don't go into details. Basically, optimization means whatever you have, we can make it better.
Yeah.
Which is very powerful. We don't have the best. In Cantonese, there's a saying: we don't have the best, but we can have better.
Yeah.
Or we don't have the worst. We can have that's slightly worse from better. Anyway.
You can have the worst.
Yeah, that's right. There's nothing really called an absolute worst or absolute best. There's always room for improvement or deteriorations. Okay, a little bit of backgrounds. I highlight these three is not because I'm trying to show everyone I'm genius. Actually, I'm not genius at all. If I'm genius, I'll be graduated from Melbourne U.
Well, no.
Sorry.
Where you graduate.
Any La Trobe member here? No? Okay, good.
I don't know.
Well, anyway, it's a good university anyway, with a lot of natures and water and ducks, just like anyway. I will show later. I highlight these three is because it's another thing I like to be sharing with especially the young and junior researchers. You have to know who you are, really. Okay, so back to 1985 and 87, when I received this award, I didn't really appreciate it. I went to buy a car, a sports car. What a waste of money. If I buy those city apartments, you see the pictures in Melbourne, I'll be rich. I don't need to teach. I'll be retired, in 87, if I have a scholarship and I buy all these apartments. But anyway, why I highlight this is when I graduated, I started to see the real world as an engineer, programmer. Even I worked in Hong Kong Telecom before. I didn't tell you retire anyway. I worked in Hong Kong Telecom
It's the
before.
first time that I know that it's Hong Kong
Yes,
Telecom.
in Taikoo Seng. It's still, it closed down. I think it opened up again. And I worked in NTU, Nanyang Technological University. So it was a long journey. And I sort of discovered that the ultimate things that I enjoy doing is still research. All right, so that's why I call myself a bookworm. And if I realize it earlier, I would start up my career earlier. I'll be promoted to a very senior professor. But but anyway, I wouldn't regret about the working experience. Only after you've gone through the bitterness, you would realize how sweet it is. So I would encourage every one of you, if you sort of know what you are good at, just keep doing it. All right. This is where I am. They more look like CG pictures anyway, but
it looked a
this
lot
is
better.
you app. Oh yeah, you're right. CG always better. We call it the P picture. The P pictures. So you won't see any cracks, you won't see any defeats, and they're artificially beautiful. I mean, seriously, they built 35 buildings in, I think, about 8 months. It was a miracle anyway. All right, so they achieved a miracle. That's it, a miracle. So other patch-up works they are still doing today. So you can see the lake, which is artificial. You can see the trees are also artificial, and you can see a lot of intelligence. Nothing. Okay, I'm not going to comment anymore. They're professionally intelligence. Anyway, so this is where I work every day, and my lab. Nothing much, but to me, a lab most important, is what? It's not those computers. It's the people. It's the people. It's a fighting spirit. So this is the first batch of our students. 99% have graduated already, and I have a quota only about 7 PhD students at any one time, because I've meeting with them daily, and it's only 7 days in a week. Yeah. So this is my team members. I'm very proud of them. Very thankful to have them. Moving forward, I have another lab as well in this company called CIAT, Zhuhai Zhongkeyuan, Zhuhai Institute of Advanced Technologies, is a branch of Chinese Academy of Science. I will later explain why anyway, because nowadays we are getting less and less international funding projects, but more and more projects from the mainland. And this is a natural connections with them anyway. Now, I have just mentioned that these are the two things: data stream mining and automatizations that I've been doing for all those years. And to your surprise, which is the next slide here, to your surprise, these two projects can expand and applied to a number of different projects which are getting popular nowadays. Like, for example, in the old days, we called it the wireless sensor network. I think that's about 6 or 7 years ago. Now they call it IoT. All right, we call it distributed, what we call it, distributed sensor management systems. Now they call it smart city. All right, so basically technological wise is the same thing, but they package it into some very nice way. So these projects allow me to fund the PhD students and to roll along with these two main things here: data stream mining and the optimizations. Now, as I mentioned that we get more and more mainland projects, and you can see the first one here by University in Beijing. We apply data mining into analyzing about cyber attack. I can't talk much anyway, and it's involved security. But the second one is about imaging, is from a Guangzhou company using AI to analyze about the lung images, which was actually very good for COVID-19, the lung scan analysis. And also the third one is about what we call the white box machine learning. We can explain about how we derive an answer and so forth. So these are some of the projects I just show you. If you so-called have a core technologies, it could apply to different areas. And this is kind of big ones. We failed one time anyway, and we are still trying put forth that is, we are building flying drones. Now, these flying drones are actually nothing new at all, especially in China. They're very good at making drones. They can do a synchronized show using 3,500 drones, you know, to display some amazing visuals in the air. But we are trying to apply a swarm of drones which can cooperate with each other for security purposes, for surveillance. Because especially in South Africa and Brazil, you know, you can imagine that we don't have, well, they have armies basically for policing, you know, but still they have to wear bulletproof and so on. So it will be safer, you know, if we have RoboCop, of course, it's the best, but safer is from the air, we can sort of monitor what is happening. And I believe the same could also applicable to constructions, you know, construction sites and so forth.
There are a lot of drones in construction sites.
Yeah, I believe so. So yeah,
we can talk more later on.
Of course, yeah, we get another seminar, you know, invite you to join in. Because you can represent China. You can represent China. We need the 5 countries anyway. Yes. Okay. Maybe I'll skip this. This is quite boring anyway. You know, books and books and books and books. Now, during the COVID-19, I was stuck in Australia. I am not forgetting about who I am. Just to make sure that I'm still alive. You know, when I'm alive, I'm hating this virus so much. I want to kill them. Okay, but the only weapon I have is a pen. So I'm using it to use my little knowledge to talk about how AI and how predictive models can use to fight this COVID-19. Well, just a little bit of my effort, hopefully for a better world. Now, I'm very poor in numbers, and in fact, it's nothing fanciful at all, because I believe there are many other experts who have higher citation, H10 index, you know, and so on. Now, I just want to show you about a pattern. In fact, in this webinar here, we are looking at the overall things. So I just keep reminding myself, if I have a pattern that goes up like this, I'm healthy. Right. You wish this is the, you know, the price of your stock. Okay, so same thing here. I just wish that, you know, I'm still strong, I am still working, and this is still going up. This is all I want. All right, I don't care about the H index or whatever citations. Okay, after all, it's just a number. You can find my publications in the DBLP. Just type Simon Fong, you can find. Now, why is that so? It's because sometimes I lost track about what I have published. When I talk to potential collaborators, I would invite them to just, you know, initially just read up a couple of my papers which reflect the latest work that I do. So go there, just do some keyword search, Control F, whatever keyword. So if you are from construction, type constructions. If you are you know, a fellow of Professor Lee, just type Rita. Then it will show about, you know, the work that we have been doing. Any topics? Yes. Okay, I just like to show that one of the latest publications is on this Ieee Iot Journal. Now, just by the pictures, this is one of the latest experiments that I have applied the both basically data stream mining and optimizations in a smart home area, in a smart home scenario. So in a smart home scenario, we assume that there are sensors that have been collecting the data continuously. And what do we do with the data? And of course, many people will show, you can use an app to check and the control. But I can tell you this is generation 1. With the AI, we can do a lot more. So this is what I'm going to show you in the rest of my PPT slides. Now, before that, just have a quick run out. International collaborations. I started collaborating with Dongguk University in Korea. I love Korean shows, I love Korean food, and I have many chances of visiting there. And there's one particular project which is quite interesting, and it started about 6 or 7 years ago. It's quite a long time. It was funded by the Korean defense agencies. Now, what they want to do is, before people were talking about self-driving vehicle, really, they put that little LiDAR. LiDAR is not a camera. It's basically a sensor which using laser to scan the environment. like for example, in 1 second or in one round of scanning, they are collecting thousands and thousands of data. They call it the data point cloud. Data point cloud. Now, that is way before people talk about big data, talk about self-driving vehicle. In fact, for the Koreans, they don't put these things on the vehicle. They don't. They put it on a small robot and then send to North Korea. Okay, so this is a kind of a spy military machines move in the territory, the enemy territory, and then try to scan the environment. And the good thing is it's accurate. It can help to pin down the localizations. So even though you don't have GPS or any satellite signals, by scanning this, they can create a map. So I think this is what they have been doing back to 6 or 7 years ago. Now, this actually related to the data mining or data stream mining, which I'm going to talk about later. So I was quite inspired during that time. My contribution basically is not the hardware. I'm not an electronic engineer, but my contribution is on the analysis, on the so-called AI part. Now, just give one example. This is the center. This is where you are. It could be a machine. It could be a drone or anything. When you scan it, we try to reconstruct the data point cloud into visual, something like this that I'm showing you here. It looks, well, compared to the video game, of course, no comparison, but are actually formed up by numbers. Could you believe it? By just data cloud numbers. So the ultimate computational challenges is how on earth you can compute so many numeric data in the split of seconds, because every second, imagine every second you're getting 30,000 data points every second.
Just one interruption. For this, like for example, that you mentioned about like the point cloud data that you try to take in milliseconds. So what kind of the equipment that you try to take the point cloud data? Is it the drone or?
It's universal.
Universal.
Yes, they put on top of a car for just testing, because you know, a car when you drive along, right? You can see buildings, you can see trees, rocks, human, and so forth. But when they deployed in the real situations, of course they won't tell me, but I guess they will be sending to Mount Sorek. This is the buffer area between the you know, DMZ zone between the North and the South Korea. So okay, so I do not know exactly what kind of weaponry or drone and so forth, but this is the little LiDAR there. You know, the LiDAR you can buy from Taobao for 600 RMB. Okay, but the one that you
600 only.
It's only 600. It's unbelievable. It's, you know, it can be even cheaper than a webcam, but it's a matter of range and resolution.
Yeah.
Okay, of course, you can build a small car and can play with a kid. You know, you can use those low resolution. But just this one here, I heard they cost about 30,000 euro to get it from Germany, because this is military grade.
Really?
I never tried to put it in the fire, but it never burned down. But it's really tough anyway. Yes. Okay. Yeah. Okay. So we try to use GPU, which is the GPU and CPU, right? Is you can facilitate parallel programming. So it's supposed to be fast and cool and so forth. So this is what I've been doing anyway. And I realized the AI that's supposed to be fast and accurate is so important. Is really so important, because you don't want it to misrecognize between a human and a tree, right? Yeah, that will be disaster. So anyway, okay, Bangkok. I love Thai food. This is KMUTT, King Mong Kut University of Technologies. I conducted some big data workshops with them, data mining workshops as well. And I was also involved into these so-called mushroom projects. I will tell you more later. Mushrooms, you know. Mushroom, yeah. Not that kind of mushroom, but you know.
Do you really throw mushroom on that? Or that is not that kind of things?
Artificial.
Right. Artificial, okay.
Artificial mushroom, yes. Okay. Yeah. But anyway, I show it because that was the momentum picking up about data science and big data. So I love to have a workshop with you one day in Xuyan when
hopefully
when everything gets better. Now this is the kind of mushrooms. They disguise in a mushroom. Basically, it's a bunch of sensors, a bunch of hardware sensors, and they found a guy from the art school. That gentleman there in black he was award winner of designing. So he designed some material which is tough enough. It's natural wood, we believe it, but the paint they use is durable enough to withstand the hot sun in Thailand and even flooding and all kind of a harsh environment. You can consider this actually for your project, for your constructions project. So they want to blend in the mushroom with the agriculture, with the farm. So they won't look too.
What kind of data that they collect in that sense for the sensor? I mean the mushroom.
Atmospheric. They have a few sensor anyway. They have an atmospheric sensor, just like a mini weather station.
Oh,
but weather stations, right? When they broadcast to us, or maybe today 26 degrees, is implying the whole Hong Kong island is 26 degrees.
Yeah.
But in reality, different part of the island or different part of the farm will have different temperatures, and they do fluctuate, especially in Southeast Asia. They rain 1 minute and then sunshine another minute. So they try to capture this kind of atmospheric patterns correlated with the harvest, the quality of the harvest, and then they try to build a model. What is the best practice in farming and so on. So it's applied for agriculture. But I think if for construction, I think it's more. You would like to measure about the vibrations, the noise, even the light pollutions, noise pollutions, whatever, air pollutions, gas pollutions. Yeah. Anyway, we will talk about it later more.
Yeah, sure.
South Africa.
Offline.
Sure, yeah. Anytime. South Africa, we also conducted some big data courses because it was heat. And we sort of invented some RFID wristband. I think now COVID-19, whoever have to stay at home or quarantine hotel have to wear something like this. But during that time, we were looking for something that is trackable, traceable, so that we know exactly where the patients are, who they are, where they have been to, and so on. So all these informations, if you think further, the data themselves, they are nothing but just data streams. All right. So this is where my contributions come in as a data analysis. CANT, okay, there's some training for about big data analytics, and also the e-health product as well. I'm an adjunct professor there, so I frequently have to go there, to La Troupe, of course. They have a big data center anyway in their business school. So I just sort of realized that, big data, data science, or even fintech is something so popular nowadays and keep us busy. I mean, as a academic and teachers, but down to earth, if you look at if you finish this webinar, right, down to earth, it's just a bunch of hardwares and some algorithms and the so-called AI, which I'm going to show to you. Well, this is the last one, Pakistan. All right, so this is the end of the world tour. Same thing, big data projects. So we sort of travel around the world, and the experiences, of course, is amazing. Apart from the food and the exotic places and the culture, we realize AI and big data is the trend. Every part of the world is pushing many projects, many fundings are available. However, it is a matter of design, how we add intelligence to it. So this is the theme of this talk today here, the AI part. All right, we have the data streams, we have the the sensor, the IoT, but what exactly are the AI and how best we can make use of it? So this is the theme, and this is why Prof. Rita invited me here. Now, this generation one, very, very typical, because if you look at the left-hand side, it could be a smart home, it could be smart school, smart factory, manufacturings, and even constructions, and so forth. We assumed hardware, no problem. You can get from Taobao. Sorry, I'm not promoting Taobao, but you can get from those Chinese factories, very good, affordable, and you can set them up easily, just like Xiaomi, for example. No one would do research with a Xiaomi kind of thing. We just use them. We just connect to our furnitures, our home appliances. So we have the kind of scenarios, and they usually would all connect to what we call a router. All right, it is go by IP addresses, go by Wi-Fi. But in here, for those commercial wireless, what we call the wireless communications network, we use some particular protocols like CBs and LoRa, which are programmable communication protocols, which is not easily to be hacked. So commercial products, usually we have the commercial protocols, common sense anyway, instead of a home router. And we send all the data to where? To a cloud. Plenty of cloud up on my head. So what do we do with this data on the cloud? Of course, the basic function is they would be linked up to some kind of dashboard. That could be your app on your phone or on a dashboard on your computer. So in case of, for example, some fire is detected, something abnormal happens, something malfunctions, it will push the notification to you. All right. And as extra functions, they will also do some analytics. Analytics means you would see the trend, the charts, in the bar charts, you will see the numbers in the dashboard. So you can know about maybe the electricity consumptions, how many kilowatts of energy you have consumed for the day, for a month. And you can even predict about your monthly, electricity bill and so forth. Now, these are the basic ones. To me, there's no AI. All right. So if anyone call it smart, call it intelligent, it's insulting to the concept. It's insulting to John Carter anyway. the founder of the AI concept. It's totally no AI anyway. But you can easily pick up any commercial product, AI intelligent. Anyway, so this is, I call it the generation 1. It's about connections and it's about automations and control. So talking about the cloud data, I have a cloud basically is a server in this Zhuhai Zhongkeyuan CIAT, and they were very keen to push these smart city projects in Zhuhai, in Guangdong, basically because Shenzhen is quite saturated anyway. There's 2 avans in Shenzhen, there's no market, so we are doing in Zhuhai, right, in the countryside. So this is generation 1. We are very familiar with it. And something like if you just click something, Alexis, please turn on the lights, that kind of things, it will respond to you. You can control using NLP, using voice, using claps, or using whatever. So this is generation 1. And I have a very short clip here. Let's see if it plays. Does it play, Rita?
Yeah. It's now showing something.
It's your Australian apartment.
Oh, okay.
It's only 2 minutes anyway.
In Melbourne?
It cost 3 million Hong Kong dollars for an apartment like this. But still cheaper than those in Hong Kong.
Yeah, of course. In Hong Kong, 3 million, you almost cannot buy anything, any home.
Nah, you gotta buy in Lantau Island.
Yeah, Lantau Island.
Zhongshan maybe.
Lantau Island, that can be cost like $3 million.
Yeah.
I'm not sure about that. So Australia, of course, is a much more sensible price, I would say.
Yeah, realistic price, human price.
Human price, yeah.
Human price for human.
Yeah.
Not for the super rich humans.
Yeah.
Okay, maybe I stop here because I think I guess you know what I mean to say.
Yeah. Home automation.
Yes, automations, voice control and so on.
The voice control part cannot hear. Probably there's no voice there.
Oh, really? You mean the video has totally no voice?
No voice. We only see the clip, but then there is no voice at all.
Okay.
So for the may need to like share screen, and then you have to choose like with voice, something like that.
Oh, I see. I think because all the audio channel to my headset, which is quite selfish. But anyway, maybe I would. Okay, it's only a couple of clips anyway. It's not meant to be a lot. Now, the second one here. Let me see if I can.
Oh, you are doing like home robot as well.
No, that one I take from elsewhere. But I want to show you. This is 1.1.
Yeah.
That means it has more than just control. You have the detections.
Yeah.
Just give me a minute if I can. Do you hear now the sound?
No, not yet. Because in Zoom that they need you to like by the time you share screen, and then you have to choose you have a bit of the screen that you can choose, like for example 7 or 8, and then on the bottom part they allow you to take share with voice or share with whatsoever.
Okay, can hear?
Not yet. Not sure why.
Can hear? Any voice? No voice. Okay. All right, so let's test it somewhere else. Now, what I wanted to show in this, now you can hear my voice, right?
Yes, yes.
Okay, good. Now let's finish the webinar smoothly. I just want to show you that this kind of little thing here, it has extra functions. That means,
yeah.
1.1, it has a detection function. Like this guy, I just scrolling over here. When it detected heat or fire, it will say something. And this thing is not an installed sensor, which is different. Installed sensor means I don't know what's installed sensor means a stationary. You can't really change much. Okay, now the idea I want to bring across is in here we have a smart home. And this is what we have nowadays. You know, everything connected to Wi-Fi, you have an IP address, and we can control them. So if we put in the so-called AI part, I guess that will be decision making. That means some kind of automatic agent that will make the decisions on behalf of the human. And in general, we have two techniques in doing that. No, I exclude this thing here. This is basically about analytics. You know, IBM, they have something called stream analytics. But what they do is, to me, there's zero element of AI. There's no AI. What it would do is it will calculate. If, for example, you can calculate the average, the maximum, the minimum, and maybe the standard deviations. You know, you can calculate something statistically based on the data, which is different from the data mining, which I'm going to talk about next. Now, there are two types of data mining anyway. One type is called the edge analytics, which is also called the data stream mining. You know, data stream mining was very original, started in year 2000. And after that, people keep inventing new terms. They call it the edge intelligence, the fog computings, and so on and so on. All right, so this is what we have, what we could possibly do. Imagine we have the data being collected from the houses, from all the different sensors. When they fit into the IoT cloud, you have to go through some kind of devices. Nowadays, they call it fog. Fog simply means instead of pushing all the data into the cloud and make a decision at the cloud there, we want the gateway to be responsive. We want the gateway to have some intelligence, you know, to be able to decide on something. So we have one thinking here. We call it edge analytics. It works in real time anyway. However, you can see it as a small brain. But on the other hand, with the big brain, they have the full data, full historical data, which were stored up in this. To me, this was called data warehouse in my in the 80s and 90s. Now they call it big data. Okay. Anyway, warehouse doesn't sound good. It sounds very low level, so they call it big data. So with the big data, we have a big archive. So it's a very nice repository, very rich repository like gold. We can discover some patterns. We can even know about the preferences, the behavioral preferences of the users in those environments. So these are the two areas that we are, you know, we can integrate it right away. And therefore, we are moving on to 1.5 here, generation 1.5. That is automation and control plus the feedback. And of course, feedback doesn't sound so nice anyway. So I invented a term called advisor. Now, what it does is, in a truly smart home environment, those Alexas, whatever command, they are not slave anymore. All right, because in my old days, they were called master and slave, you know, server and client, that kind of things. They are not just a device that will listen to command and then they will perform a function. They will be able to know, for example, hey, you've been sitting there for too long. It's not good to your tummy. You should get up and do some exercises, you know. And maybe you watch too much TV. You'll be watching the whole day about TV, you know, which is bad for your eyes. And they may even tell you that the house air quality is bad. The wet floor is detected. Be careful when you walk because you may slip on it. Maybe your iPhone charger is too hot. Okay, especially you don't buy the original ones. They burn. Really, I think in Hong Kong there was a case, right? Someone get electrocuted to death.
Yeah, a number of cases, not just one or two.
Not just, oh my God, yes.
Yeah.
You should really have this smart home to monitor anyway.
Yeah.
But ironically, if they can afford a smart home, they can also afford a real, iPhone product. But anyway.
Yeah, you are also right. Except the smart home is made by you yourself. Then
yes, we have to make it very cheap, cheaper than the original iPhone charger.
Yeah. Right. Right.
Yeah. Anyway, yeah. If you keep a pet, it's even more interesting. You know, your dog has okay in your room, and you will smell it in 5 seconds.
Really? 5 seconds in 5 seconds?
Odor, we call it the odor detector.
Okay.
Yeah, if someone farts, you will also know anyway. Or even you're going to predict, you know, after you're eating too much pizza, you're like 4 minutes later, you're going to fart, so you better walk out.
Okay.
Yeah, this is AI, you know. I know it sounds fancy, but it's AI. Like your cat just jump out of the window. Survival chance is 40%. You know, it's a bit like science fiction movie.
Is it really that accurate? I mean, that it can tell you about like your chance of survival is at 40%. So it means that you have to have got another programming inside them.
I think you need the data. Like for example, if you keep 100 cats before, out of 100
and then they jump out of the window, and then see how likely that they.
That's right. Out of 100 cats that come out of the house.
Yeah.
60 die. I mean, this is just a concept theoretically.
Yeah.
Big data. No, seriously, big data. Of course, no one will keep 100 cats and throw them out of the window. But if you're the big data, people who live at about the same height of your floor, who keep about the same breed of your cat, right?
Yeah.
Then you can know the survival chance. Or even a human survival chance, you know, those who suicide jump off from the building. Or for constructions, you can estimate, you know, when the concrete come down, you know, or maybe someone didn't wear a safety belt, fall off, you know, what's the survival chance? That can be computed theoretically. Yeah, when you have the big
data. But then you have to have a lot of data on that. Like, for example, how many people that they do not wear the safety belt, and ultimately that they commit suicide.
Yes. You see, I don't want to make the example too scary. So I use cat. So I use cat anyway. Okay. Now this is interesting. Now your boyfriend supposed to visit you by now and is late for 7 minutes and 2 seconds. So again, it's a matter of data. So if you can connect to the traffic big data, you can even Google Map anyway, you can have the estimate time of arrival. So if they can have access to your diary, to your phone, you know, assume that nowadays you talk to your boyfriend, you know, using a phone more than your voice. So they would know that what's happening, who is coming, and if they are late, you know, they can even track about, you know, how late they will be. And the last one is I can think of is your plant is dehydrated, you know, too long, you haven't watered your plants. Please water it. You can even predict that if you continue to let it dry, it will die after, you know, how many days. Something like this is very simple, and it could be done. We call it 1.5 with feedback. So that is, So this is the kind of examples I'm giving for a smart home. And of course, it can be extended to building industries and some other things as well. Now in here, this 1.5, we need an advisor. Okay, it's just an advisor. You can call it AI anyway. But to me, this guy here is more of an IA. You know, people confuse about AI. They should be called IA. IA means intelligence agent. Definition of intelligent agent is the agents could be a software, it could be hardware, or something or someone that will do the work on behalf of a human. Right? That's why you call it an agent. And these agents would have some kind of intelligence capability. So if we have the data analytics here by doing data stream minings, and we can program something called AI, you know, Alexis, for example, an advisor, this advisor could channel back to the user as a feedback. Now, this is important because this IA, okay, Ieee intelligent agents could take a form of a home robot. It could take a form of a hologram, or maybe just an app. So it depends on your budget anyway. If you have a budget, you build a robot. If you don't have so much budget, a hologram. If nothing, you just build an app. It doesn't require programming. So just some examples I'd like to share with you. The advisor would be able to tell you, suggest you some exercise, suggest you to read some books, suggest you to open the window. Now, these are corresponding to what was being detected. You were sitting there too long, watching TV too long. Someone fart. Okay, you open the window for ventilations, and auto activate a floor cleaning bolt, which is very common nowadays. Those vacuum cleaner bolts that go around and clean. But the current generation is they are pre-programmed. They are pre-programmed to roam around your house. But if you connect with IoT, they can go directly to the places where it's mostly dirty, like a dining tables, that sort of things. And maybe auto turn off the socket that the iPhone charger was connected to, auto open the window and activate cleaning bolt. And the cat, I don't know what to do anyway, already jump out, maybe auto call the ambulance. Or even call a pet shop to recommend you another cat if the survival rate is, I don't know, less than 40%. Okay. If your boyfriend is late, maybe auto call him and check his whereabouts. No, being late is all right, but not in a place he's not supposed to be. Anyway, so this is the intelligence. This is what it means to be anyway. And this is the ultimate goal of IoT. IoT means we have IP version 6, too many IP addresses. Everything can have a recognizable identifier. So if the plant is too dry, too high, going to die, you should have the water, auto watering device automatically turn on, activate on. Now, this advisor here, not only applicable to the environment, because environment, why is environment for? You buy a 3 million house or apartment for what? For ourselves. So our body, okay, our body, according to the Holy Bible, right? Our body is a holy temple. We have to look after. So this is a holistic data analysis that I've been proposing with my partners. We use wearable sensor as well and combine it together with the sensors that we live with, external sensor and wearable sensors on our body. And also, not only to measure about our ECG, EEG, E whatever G, we also have the what we call the Iot Intelligent Mattress to measure about our sleep patterns, which is the technologies is available right now anyway, but they're individual. Like you buy a smart pillow and you buy a smart fussy washing machines, they are not connected. All right, and there's no AI. All right, even though it says you got AI fussy logic, the washing machine, what it does is, between the high and the low power, it try to measure about the weight of your load, and then you calculate if it's over the threshold, you turn the high power over the under the threshold low power. That's it. All right, it has no intelligence. So what I'm proposing here is we have sensors, that is around us, something that can wear at the same time, and also the home sensors as well. So all together with all the sensors, we can achieve what we call the generation 2, the second generations of smart home, which has the basic automations and control, and also plus the health advisors. Now we can add in extra functions here for the COVID-19 anyway, like you are reminded to wash your hands frequently, and you would have to top up your mask, your alcohol. But anyway, in this scenario, which is called the version 2, we should have a virtual doctor in our house, like this little robot here. Or it could be something that flies in the air and then deliver you the vitamins, the drugs, and so forth. Or it could be something virtual that, like an app avatar on the cell phone. So you are detected to have high blood pressure now, for example. Take a rest now before your high blood pressure gets too bad. You fainted before that. And you may need some vitamin D for your insomnia because we detected that you didn't have a good sleep. And you will auto open some curtains to let the sunlight come in, for example. You can detect that you look tired. You're advised to sleep more. You look thirsty. Drink some more water, for example. And you're reading now. You should turn the lamp on. And if you're slouch, Slouch means you crooked your back too long. You should sit straight up. And you took some sedative medicines. Go to bed now. You are stressed and so forth. So all these advices, they are the true forms of AI, which knows about your conditions, and they would be able to advise you as well. So I think that would be a, it sounds like science fiction's half a year ago, but I think nowadays it's very common now. We call something called telemedicine. That means over a phone, you see a doctor. You over a phone, you see a doctor, and a doctor over the other end advise you about what medicines you take. Stick out your tongue, take a photo, and then on the phone, they will do all the consultations to minimize the face-to-face contact. So this is a natural kind of progressions that I foresee. So we have a list of sensors here, just for examples. Sensors on your body and sensors on the places where you live. Now, this, I think, would be the fundamental step. Once you have set up everything, connect everything with the data that you collected, big data in and out, naturally, you can build the AI on top of it. So this is quite cool. And I really like Rita's job because her job is challenging, okay, because she needs to take care about the health of the workers and the risk and also the safety. Am I right? And also have to be sustainability, responsible to the not to the if responsible to the boss who put the money and build the constructions, responsible to the workers, responsible to the government, to the environment. Many things. Yes, there are many dimensions of applications that where AI can come in. Amazing. Now this mean to be a video. But I can later share with you that video clip. It's quite cool anyway. The robot is nothing fanciful. You might have seen it. I think it's called Jimbo or something. This video clip is not commanding him about like tell me a story, show me a joke, that kind of stupid thing. This is a concept about algorithm self. These conversations, if I'll be able to play it on the video, the person actually asks Jimbo about who you are. How do you feel? Do you dream? What do you wish to achieve? Now, this is something more than what a machine should do. Anyone watch Terminators? Yeah, of course, Arnold Schwarzenegger, right, was very impressive. He got the microchip. That was the so-called AI chip. But you know what? The first movie I watched, Terminator, I wasn't impressed because to me, it's not true AI. He's just a killing machine. He was programmed to just hunt down using facial recognitions, John Connor, and John Connor's mother, Sarah Connor. All right, so it's just about facial recognitions and the muscles and a fighting skill. So this is basically a programmed machine. It doesn't have much AI, but the latest, I can't remember, the latest version of Terminators, I'm quite impressed because Arnold, of course, he's old already. He aged and he sort of retired in a jungle house. He started to think and reflect about life, the purpose of life, why he exists, and what is the meaningful things to do. All right, so this is the ultimate level of artificial intelligence. Unfortunately, it doesn't have much industrial or commercial application, so that's why no one really talk about it. It's good for philosophy anyway. If you think about the ultimate philosophy, a machine can attend like a human, like meditations to try to find the true self spiritually. This is the ultimate one. But what I see is the middle part. That is based on some hardware, some sensors. The AI would do the intelligent functions. That's why I don't call it AI. I call it IA, intelligent agents. And then in marketing, they put the big one, AI. Yes, Ayashi. I see you. I'm finishing quite soon, and we can chit chat after 4 minutes. Deal? Rita?
Yeah.
Oh, okay. The voice is still okay, right? All right.
Yeah. Okay.
Yeah, that's normal towards the end of the lecture, anyway.
No, not really. But then can this one be programmable, or that this one is in your office? The Jimbo.
The Jimbo. Someone did a comparison. They bought all different robots. When you command them, the basic function, right? Can you dance? Can you just play a song or crack a joke? This is so standard. So someone want to test the AI. Really, someone want to test the AI of the robot, the true AI of the robot. You know, it's just a simple question. Who are you? You know, who are you?
Because it is like all of them. I mean, by the time we talk about the brain of the robot, they are the same. We actually have visited a lot of robotic companies actually recent 1 year, and then most of them they have got more or less similar stuff. I mean, if we talk about like the kind of like artificial intelligence that they have, no matter it is robot A, B, or C, they are more or less similar.
Yes,
because they share
true.
the same brain.
in the operation level, yes, they will fulfill. If they are social robot, they can use NLP and chit chat with you. If they are surface robot, they will perform basic functions like bring the dishes, clean the floor. But if you want to test the true AI of the robot, you just ask the questions. What do you inspire?
What do you inspire? I think most of them.
What do you wish to achieve?
most of them cannot answer you. I'm pretty sure because most of them they just say that I don't understand what you're talking about.
So no idea. No, I don't know. I'm a robot. What do you expect?
No. Later on, after 6, I have got a meeting of robots, so I can actually try to ask the question that you just say. So what do you want to do, and what kind of inspiration?
To us, to you and me, these questions are important. You know why? Because one day, if you don't ask these questions, and if you can't answer these questions, you become a robot. Yes. So, vice versa, if you want a robot to become like a human, a true human, he should have some kind of thinking. That's what I put here, the ability to think, reason, and also learn by itself.
But
I may be a bit stubborn. When I learned AI, I actually learned Lisp. L-I-S-P, Lisp. Lisp is a kind of programming language which can frame the knowledge, and the knowledge will derive upward. That means if you know a fruit is red color, is round and sweet, you know it's apple. All right. And if apple you eat every day, you become healthy. This kind of knowledge derivations. So to me, AI is ability to have this knowledge reasoning and be able to learn by itself. If it can't do it, it's just an IA. That means it's just an intelligent agent. It just do the work to replace those factory workers. But commercially, this is what people want. They don't want to pay high salary to human. They may have leave, they can fall sick, and they can a lot of 很麻烦, all right? So they want robot to replace them. So as I say that AI, the high level one is more for philosophy. But it doesn't have much commercial value, unfortunately. So when there's no commercial value, there will be less attention.
What they say is that most of the robots, they are making a loss actually for running any of the robot sale. If we just talk about like selling the robots out. So what they try to make money is out of the others, not just by selling the robots. Because the robots in itself is quite expensive in development in itself. What they say?
Well, I think it's a priority. It's a matter of priority. Every company, every industry with a certain amount of budgets. So they want to maximize the effect of the budget. So they rather put the money into something that will have a big return in a very short time. Like if a human can do the job in 1 hour, the robot can do it in 1 minute, they will just take the robot. They don't care about much of the AI. The AI part is the, what they call the, the cherry on the icing, the cherry on the cake. The AI basically is to try to speed up the job or to cut the costs, which is a slightly different directions from scholar point of view, from theoretical point of view. That AI is supposed to be a higher form of intelligence, at least should be able to think and reason.
From the computer science perspective, is it that robot nowadays, what they try to like chit chat you and then response is rather weak? Because the one that we see in most of the robot company in Hong Kong is they don't really understand what we are talking about.
I think that's why NLP nowadays is so hot. Naturally we can converse and you can understand each other. In fact, it have a high implications. When they have AI and a robot at the back end, let's say with an AI doctor who can diagnose more accurately than a human with all the big data, all the knowledge, but it has to communicate with the grassroots. It doesn't have to be a professor, to see an AI doctor. It could be anybody, even a kid. to ask stupid questions.
Yeah.
So I think this is why the NLP part is becoming so popular now.
Yeah, but then it seems that it is most of them are quite stupid. But I'm not sure whether or not that it is because those robot company they are not AI expert or whatsoever. It is quite stupid that they can't really understand the thing. So I just wonder if like these robots in the computer science field, is it true that most of these in terms of like social ability, the social robot is still rather weak in this area?
Well, I have a connection with a company in Beijing called Turing. Turing. They specialize just in this, just in NLP, making those conversations, the ability to converse as smooth as possible. So they just focus into doing this, and they told me that, the founder actually was my student anyway. They got the funding from the Beijing government, a lot of money. And the application is so big and wide beyond our imagination. And of course, the financial revenues that they bring in and so on. So you can see that this kind of research have to be focused and have to be supported, not just from a single investor, because single investor we expect the return very, very soon. But it has to be supported by the government. And the government can connect the output of the research into factories, into industries, into those big giants, And I think China is doing quite well in that aspect, given the economy is relatively stable compared to the rest of the world.
Yeah.
Well, I agree with you. I mean, this chatbot thing just started in less than 10 years ago, and currently becoming more and more popular.
Yeah. Oh. What happened to these? I have to
Rita, as a host, can you maybe switch the screen to her?
Switch the screen to whom?
To this user called it disappeared. Oh, from India, I think. I think she want to tell that she's from the. She can chat. Where's the chat?
You can actually chat. So who is this one?
Hi, we have a friend from India. Ashaya. Sorry, I didn't catch your name, but I think we can go to the chat functions.
Yeah.
So by the time now we have a half an hour for chit chat.
Yeah. Yeah, you can. Sorry, please continue. Sorry, Simon.
Oh, okay. Sorry, I'm waiting for the chat anyway. Okay. I think I can just stop here for these sections, and I can carry on the PPT. Okay. The rest of the PPT that I have is basically talking about. I will break down the AI. When I talk about AI, it's very general kind of concept, but I will break down the AI into several data mining functions, and from the data that I got, I mean from the past year experience and the current projects that I have, I would like to share with everybody, and I would like to invite you to think about and to tell me about what kind of AI functions can be applicable to each one of the scenario.
Oh, okay.
I think it's a kind of interactive discussions later on.
Okay. Yeah. Thank you. So thank you, Simon. So we will have got the oh, by the way, anybody know how to block somebody's writing on the screen? Actually,
I think you can't.
I think I have before, but I forgot how to do it because I have actually read that before, but I don't know how to.
Okay, it's all right. I mean, it's not.
And sorry, I know how to block.
Oh, thank you.
You need to log in your Zoom account on the website, the zoom.us, through your account.
Oh, okay.
And then there's a settings for the meetings, and then there's a chat box to check the participants cannot write annotations on the presentations.
But during the annotation
the
of the presentation, I think
yes.
I can also stop them as well. But I forgot how to do it.
You need to stop the annotations from the Zoom.
From the Zoom.
Zoom US from the website, not from the applications itself.
Because I think I have I have read that before, how to deal with that, but then I just forgot because I never had this kind of experience before.
Yes, you can try this way.
Let me try that. So sorry. Now for I think for now that we can have got a short break, or you can just introduce yourself for whatever thing that you would like to share.
I go and get a drink. I'll be back.
Yeah. So we resume it at 3:30. So we resume it at 3:30. So Simon, you're also doing something that is related to robot?
Sorry, Rita, I'm here.
You're also doing something that is related to robot?
Just hang on a second.
We are having a social robot meeting.
Oh, I see. Today. Oh, social robot.
Yeah, that's why that is like I just asked about like social robot stuff.
Mm-hmm.
But then I find it is like most of them, they are rather stupid. I'm not sure whether it is because that my knowledge in AI is not strong enough, but I think most of them, they are quite stupid. And social aspect, is it a weak point of robot at present?
Well, from research point of view, my involvement in the social robot project basically is to find the most powerful data mining algorithms.
Yeah.
They have done a lot of lab tests anyway, sort of confidential, but they gave me the data, the benchmarking data.
Yeah.
In order to keep the company competitive, the data mining part or the machine learning is most important, because if you have the best algorithms, the best accuracies, the conversation will be smarter. Okay.
Right.
Yeah, like for example, it won't misunderstood the user, or maybe we call it a hit rate. That means every conversation, Q&A, we should hit. The kind of hit rate is even between human, between two friends. Why they click is because where we talk about the same language, but it's more than the language, the grammar itself. We talk about the same jokes, the same stupid things, that kind of things. It's very, very delicate. It's not 1 + 1 = 2. So that kind of things. If you think about you replace a human brain, like you use a machine learning, deep learning to do it, it's actually very, very sophisticated. It's difficult. So that is my comment from the research point of view.
Yeah, because I think it is quite difficult in terms of like social robot, but then robot for like transportation, those repetitive work, I think it would be much more better.
I'm not sure the applications, because to me, social robot, as I observe on the market, mostly are for kids anyway. Kids, as long as someone talk to him, they'll be happy actually. I'm talking about those 6 years and below, all right?
Okay.
Not those very intellectual ones. I mean, not the tuitions, the tutor you can't anyway, who teach mathematics, you can't, but to just keep them company, especially young age, preschool age, as long as you talk to them, you sing to them, it's a human voice, I think it's good enough. But if you're talking about some legal robot, I think we have to be very careful. Not only, because we cannot afford to say a wrong word, legal advisor, it's just one extreme example. So I'm not sure the kind of requirements from the constructions,
No construction, but that is just like because we have got the we were talking about like social robot, and I just wondered, because I think that it is one of the weak points, but I'm not sure whether it is my limitation in knowledge in AI only.
No, it's not actually. It's a matter of, I just mentioned two things just now. From the research point of view, technically you may need to get hold of the best machine learning algorithms. Deep learning is a way to go anyway. That will give the best performance in terms of Q&A. However, the other point I think is actually the applications, the discuss scenario. You know, when we say stupid chat, actually I am not someone who like to chat so much. When I'm bored and chat, I will feel more bored. I will feel more upset anyway. Yeah, that depends on the individual. So chattings, I think it really depends on the scenario and the context.
Yeah.
Yeah, you know, when I'm down and depressed, I don't want to talk to anybody. Really.
No, probably go talk to the robot because a robot is nobody.
Why robot? I look at the cats. I'm happy. Okay. We don't need to talk. We just look at some small animals, you know. You know, and we can talk to animal. Animal just listen, you know.
Yeah.
So yeah, it depends. So for how would say, like mental therapy, psychological therapy, we need another kind of robot that is compassionate. It doesn't have to be very intelligent, but you know, compassionate and understanding, and preferably not to talk too much. You know, you know, when you are so down. That depends on mood. Just like when you are down, you don't like to watch comedy movie. But sometimes, you know, people may like otherwise. But for me, yeah, that depends on the applications.
Yeah.
Wow, good. Yeah, many projects. Yeah, many webinars. Keep you very busy.
Yeah, very busy actually. We have got a lot of things that is like doing all together, and then well, yeah, very busy. But then I just found it is like I'm not sure whether or not that is like I think in terms of like the thing that we see, that if they try to I mean, most of them, they are quite silly and then they share the same brain. So this is what I have observed. I think it is more or less that they share the same Google brain. And then that one is not really intelligent, I think. And then I'm not sure it can be programmable and then extendable. I think it should be able to. But then, well, whatever I see is like, well, most of the answers, they are like not answering the questions that we are asking.
Yeah, many people confuse between automations. It could be fully automations or automation with a bit of intelligence, and the intelligence is defined by you make the machine to do something like what a human can do. You know, this definition is very broad. A machine that can do something a human can do. What it means, a human can do many things. Human can do other things, can do monotonous things, or they can do some intellectual things. So because of the broad definition of AI, and also because that the commercial value, most of the AI were being commercialized, market in such a way that it just perform, you know, one or two little functions, and then they call intelligence, and they call it AI.
Yeah.
Yeah.
But most of them are not that intelligent, I think.
No, not at no, not at all.
It's just like they consider too much. They think that it's like they can respond to you. And then what I think is that even Siri, they cannot respond that much.
Yeah, that's right. Yeah, that's right. You know, day and night I've been working with AI. I started to feel a bit lonely. And when I look up in the starry night, I ask myself, you know, what is AI? Why am I doing AI?
They really think too much about that. There's like they think that AI is just like fiction that we have seen, like all the film that we have seen, that they are that.
You know, I should work with some marketing friends, you know, in marketing and business, try to do a survey. Out of 100 commercial products in their packagings, they will have AI, intelligence, smart. These are keyword that printed on it. And when you really had the expectation and you pay the money and you get the device, it's just disappointment. You know, it's just disappointment. It's just some kind of functions that is so basic. And they call it intelligence. It's insulting one's intelligence. It is insulting our intelligence. But anyway, this is the world as it is. You know, from their point of view, they just need to market it so that they will sell.
Yeah, but I don't think they are that. I mean, what we have seen or what the people expect, they expect too much. I think most of the circumstances, just like what you say about like prediction, it is not that accurate.
Precisely, yeah. And I admire your career and your profession, because I think the job satisfaction they come in when you have succeeded something, and that's something you can see that it put into real use, and you can see the result, the benefit, and it really save life, save causes, basically better, sustainable, happy, happy. I mean, in contrast of a real AI expert who is overwhelmed with the jargon called AI, gimmick AI, 发疯了. Really?
Yeah. But then all the people now are talking about the same thing. But I think it is like, well, it is not that.
Well, it's just used to it anyway.
Yeah, too much about the AI. It is talk about like all the way through about like everywhere about like AI, but then
That's right.
It is not really what we can see, and some people just say that they can replace us, and then well, I don't think so. It's just like machine. I think it is like much more intelligent than ordinary machine only. But
exactly,
it is not that intelligent at all.
That's right. Let me just fast stretch a little bit about finance, for example. Do you think AI can accurately predict the stock market prices?
Of course
Of course not. Yes, but there are many products. There are many people who try to sell it to you. They have the best team, the most sophisticated deep learning, blah blah blah.
But this is not really true, I think, because like for prediction, if that is that true, then most of the computer scientists, they will not work anymore. They just stay at home and then buying and selling the stock.
Precisely. Yes. I heard that like the Alibaba, even the Google team and IBM team, they have the best the team of AI experts and also the finance experts come together and make the best predictions and so forth. There's a lot of these kind of news popping up nowadays. But in contrast, I know of my uncle. He doesn't even go to university. He know nothing about AI. He just read about newspaper, horse betting. I'm talking not stock market, horse betting. He just read about the newspaper every day. He just read through many numbers.
Yeah.
And then like out of 10 times he bet, he will win at least 6 times. So in the long run, he still make a lot of money.
Yeah.
Yeah.
But this is not anything about AI, right? It's such an amount that really.
It's not AI. This is NI. It's natural intelligence in our brain. It's natural intelligence in our brain. Just like stock market. I bring up the example because, to me, the up or down of the stock market is actually you can't really look into the past pattern to make a regression or projections. Even you have the best algorithms or the best AI, it's much to do with human. For example, Donald Trump. Okay.
Yeah.
When he's got some crazy idea, he want to have a trade war, he want to ban TikTok, want to ban China, ban whatever. Certain stocks will go up or go out or go down. So it's much to do with the policies of the politicians. If you agree with me, I mean, it's ultimately the human is actually playing.
Human is much more
the invisible forces.
Yeah, I think so, because it's like I just wonder as if like my technique in terms of the AI is not strong enough, but that I don't think that it really works, because after talking to like so many like for those who are doing and working on the AI, I found that they share the same viewpoint. I mean, most of them, they just tell me that, well, if there is that intelligence, then you will not see me in the university, right? Yeah, so that I think it is not that intelligent, but most of the seller in the market, they just talk about the same thing. That is, they allow them to by using this programmable language that is voice.
Wait, hello. I have a question.
There is a question.
Oh, good to have someone to ask questions.
I have a question about the IA. So the IA is only follow the program we are setting and the data connection, the IA, or this is AI?
Well, AI is a concept, first of all. It's just a concept anyway. It can take in many forms. Usually it will be taking some sort of executable kind of programming forms together with the knowledge management abilities. So you can do the reasoning, you can access to the data and so forth. Now, IA, the name agents, it simply means is a something that once again could be software or hardware that will work on behalf of human. And this kind of agent, it could be as intelligent as somebody or something that can make decisions. Big decisions, minor decisions, or small decisions. Usually the IA, the agents, should be able to make small decisions. For example, if it detects the temperature is too hot, they would make the aircon colder, and vice versa. You know, it based on something that the data that comes in and make some small decisions.
So AI is more automation.
Sorry, AI?
So I think he wants to ask about like the difference between the two. So AI is more in terms of like automation or what?
Yeah.
No, to me, AI is just a concept, like a brain. You know, it got nothing to do with automation. You don't even need automation. Like for example, AlphaGo, you know, the computer that beat the chess player, there's totally no automation. You know, it will just, you know, process the informations and come up with a decision, and that's AI. So AI, you can think of it as like a brain. Automation is your legs and arms of your body.
Oh, okay.
Yeah, there are two levels to me.
So it's like intelligent agents. It's just like those who are like workable stuff.
Yes, usually.
Without really the true brain.
Yes, I think a little bit of brain. Yeah. Well, if you put more brain juice, it means the cost is higher. So if you manufacture these kind of IA agents that mean to replace human, is quite cost conscious. We want to make it as cheap as possible. Otherwise, why anyway? Why replace human? It's not because we hate human or we want to fire them, but because the cost, the running cost, the investment cost, they are lower. And because we want the cost to be lower, usually you don't want to put a very sophisticated chip or to invest a lot of resources, R&D resources, to make the agents intelligent. So as long as the agent will perform certain functions, like for example, a spam filter actually is an agent. You know, spam filters in our mailbox, it will auto detect, it will scan through the words in incoming files, and then the IP addresses, the sender, and so on. So if we can think that this may be a spam mail, it won't put into your inbox. They may put into a spam folder. So this is an example about the IA, and yet the agents will do some automation. That is, you don't have to really click open every file to read and then decide whether it's a spam or ham. It will do on your behalf, and it will automatically, the automation, put it into a folder, into the spam folder. So that is IA. One example anyway.
We have got 5 questions here. So the first question is about the artificial intelligence in business area. How is the AI system safeguard the business transaction, and how it operates in detecting or filtering the fault information?
Wow, that's not one. It's not a single question. Okay, maybe. Do we have it on the chat?
No, but I think I can copy it.
Yeah, that's great. So everybody can see the questions.
Yeah. So we have got like 5 questions here.
No problems.
Hold on a second.
We have all the time until maybe 5 p.m. I'm fine. I have a lecture. I have a lecture at 7. So you know.
Okay.
So 5 is good.
So we have got the first question. That is like how artificial intelligence in business area. How is a AI system safeguard business transaction? How it operates in detecting or filtering the fault information?
Okay. It's not on the chat box. Is it on the chat box?
Yeah. I have put to the chat box now.
Strange. I don't see it.
Really?
I don't see it. Yeah. Do I have to close it and then open again?
Can you see that? Alternate H, or the one that is besides the share screen.
Okay, hang on a second.
Yeah. Then you will see some question there.
Maybe exit the full screen first. And I still don't see the questions. What do I do? Okay.
You hit the chat.
I got something like this. The last question is, Professor, what I want to ask is, all the data about US is in AI products. So how do you protect our information security? Is this one? Oh, I got it. I got it. Yes. Okay. Do we see my highlight? Okay.
No.
Let me just read out about AI in the business area. How is the AI systems safeguard business transaction? The answer is, I think AI doesn't really safeguard anything. What it does is it will serve as a decision maker, is a brain. So fraud detection is a very mature field in transactions in the finance, and in the old days they called it watchdog anyway. They just called it watchdog, which is a nickname for a piece of software that would detect at all levels. We think about the communication levels, cyber attacks and hacking, the kind of suspicious IP addresses. That level, we will be doing the checking. There's no AI. We don't need AI anyway. On the higher levels, we will check into the content and the context of the transactions. For example, money laundering. Money laundering means a large amount of money, frequent kind of fraud, a lot of transactions. So in the past, people have been doing data mining. They have been programming about what, basically we put into two groups anyway. Some transactions are recognized as normal transactions, and the other group of transactions are recognized as suspicious. And once again, this is basically about building a decision tree, or it could be a neural network anyway, to distinguish the characteristics of the two group of transactions. So the whole things, I think, will be working together from the bottom network security all the way to the fraud detections. But of course, anybody can just brand it or call it AI. But to me, AI is, as I mentioned before, is more like, it's a higher form of intelligence that something would have the ability to learn, to reason, and to derive. Usually this is more towards to the knowledge engineering, decision making. But for fraud detections, it has been going on for very, very long time, actually. Even before World War II, in human civilizations, in the banking sectors, when they started, they have got the encryptions, and they have this kind of watchdog programs. They will safeguard the business transactions. Well, so I hope that I have answered the questions. So what's the next one?
The next one,
pandemic. Is it right? Pandemic. We're talking about COVID-19. Yeah. How can AI stream fast in a high volume of data in the Internet of Medical Things? That's interesting. Are there any challenges in AI applications in healthcare system? Very good. I just got a special issues in IOMT, the Internet of Medical Things. However, when we fight the pandemics, basically we are doing two things. One is we are doing the prevention. That means we are doing the screening. We are doing the COVID tests, the pop through the nose or the swab test, and then we have this nucleic acid test as well. Unfortunately, I think none of them would involve any IoT anyway, because we need laboratory tests, the chemical tests, and even scanning the lungs. However, a little bit confidential anyway, but we are proposing with some Shenzhen hospital, we are looking into a holistic approach. That means we are using AI, which is deep learning, to analyze about the lung scans from CT scans and the X-ray as well. CT scan is most accurate, but the problem is is also easily get contaminated because someone actually have to physically insert into the machine, rotate. I mean, you can't stop him from breathing, even though he wear mask, but chances are the whole CT scanner will be infested anyway. So the other alternative is X-ray, because X-ray is remote, relatively is safer, but X-ray may not be so accurate because we don't see the 3D, images. But nevertheless, this is where the deep learning, the image recognitions, pattern recognitions, you can call it AI if you want to. This is how they come into play. However, for the IoT, that would be more to do with, I think, sensors measuring ones about it. I'm talking about prognosis such as maybe measuring the blood pressures, the breathing rates and the SpO2, the oxygen concentrations, in your blood. So all these, we try to be as contactless as possible. All right, even for the medical staff who may have a shield and a suit. So I think this is where the IoT would come in. The measurements would be taken without any human involvement. I think this is what you mean. And of course, the third one I wanted to comment is the vaccine, which is it got nothing to do with IoT, unfortunately, but it's bioinformatics. It's about the protein docking simulations and so on. So I think this is all about how we apply technologies in the pandemic. Yes. You can go to Amazon.com and buy my book. I've written books about that. Just joking. As a friend, I'll send you a free PDF anyway. You just have to sign the book to thank me. Okay. Don't waste your money. I have the PDF anyway.
No. Just let us know about this. I'm interested in that as well for the internet.
I'll send you tonight.
Yeah. Okay. Sure. Thank you.
Because for medicals, because of COVID-19, they are more inclined to use robots, to use AI, to use whatever they can, because no choice. People are dying. If they don't do it well, they may die as well. So they use whatever we have, even though it's so mature. So crisis, behind every crisis, there are opportunities. Okay, so next questions. How AI assists government online services in knowing the user's expectation in better serving the citizens? Of course, like what I talked about before, we use automations in terms of maybe APP as much as possible. So in the past, a lot of government services that involve about physical contact, like over the counter, we encourage them to just do the e-version, send me an email, do it on the APP as much as possible. Now, how AI come into the picture? Because in that case, you can see that to facilitate the kind of customer services, we need IA, intelligent agents. Yeah. Instead of a real doctor, for example, it would be nice to have an AI doctor who have access to the knowledge, access to the big data, who can diagnose, who can make decisions, and he won't get infested because it's a program. Right. So similarly, for government services, we will more look into NLP, because why human? Like someone presentable, talking nicely to you, nice girl, whatever, because we want to provide a good service. So likewise, if you can use a APP, use an avatar, which is virtual, who can do the same thing, who can do the Q&A, expert systems, you ask the questions and he will be able to answer you. To give you the right information. Even now, I think in Alibaba, Taobao, they call it the honey chat. It is by AI anyway. So it's not by human. So it would enhance the government service, and it would eliminate as much physical contact as possible.
Yeah.
Yeah. So next questions. Before traveling, people would choose to search on live viewing. Other people comments in the scheduling the itinerary. Is there any AI in Macau that can better? Okay. Quite unfortunate, because of pandemic, we don't have tourists. It's so ridiculous in Macau. If you are non-Macau citizens or resident, you can't even enter. You can't even, yes, you can't even enter. This is why my family is still stuck in Australia. I'm so sad about that. They can't even come. So fortunately, I come because I have to work here and I have got a Macau ID card. That's why Professor Rita cannot be invited to come yet, okay, because of these stupid restrictions. However, they're going to relax this with this what they call the health code, the Guangdong health code. They want it to be compatible with the Macau health code. So once this compatibility is in fact, it's already established, but in Hong Kong, I think they're still working on it. So with the compatibility of the health code being done up, the Guangdong tourists can come into Macau, provided that they got a green code. That means COVID-19 test negative within 7 days, and they got a quota. So we are expected to receive a lot of them before 1st of October, the long holidays. To answer these questions, are we using any AI and applications for tourism, for recommendations? Yes and no. Yes, because we are building some NLP bot, like a kiosk anyway. You can actually chat, 你要去哪里啊? You know, 喜欢什么, you know, so they can automatically customize some kind of package tour for them. Now, on the other hand, because Macau is so small, right? Even though you never been there before, I mean, you won't get lost. And if even you get lost, it's a fun experience anyway. So many people just have a map, basically the bus map, because it's so difficult to get a taxi in Macau. But taking buses is a common transportation. So they just need a map with, sometimes they have the predefined roads. Let's say you like historical places, they will show you on the map where to go and you know, and so on. So yes and no, we don't really need AI compared to some big cities or big countries, you know, to assist the tourists. But still, we want to play with the AI as something fanciful, you know, to make it cool. Because I think in mainland, people would like to try any cool new things, especially about AI. Am I right, Rita? I think you told me that
I think
some time ago. Yes.
Because they have so many people, so they are willing to try everything. Because
yes,
1% that they want to try, that you can imagine how many people that they would like to try.
Yes. But that's very interesting question, because Macau basically just tourism. Other than tourism, maybe casino, which is also part of tourism. You know, F&B also tourism, accommodation tourism, tour. You know, just tourism anyway. That could be a big topic, another seminar. Now, these questions: can AI help do negotiations in B2B? The answer is yes. It's definitely yes. Back to 8 years ago, I had a PhD with Tsinghua University. The topic was new, something new 8 years ago. B2B automated negotiation agent. All right. We call it IA, because from that time onwards, I can call it AI if I want to, but you know, it's insulting AI. So I call it IA. How it works is basically we have some parameters when we negotiate, like your baseline and how much you want to give in, how aggressive you are, how, you know, we can set these parameters hidden. So when two agents come together, they can negotiate. If we just negotiate on a single variable, we don't need AI at all. Let's say price. Let's say you want to sell as high as I want to buy as low as I want. Let's do a compromise, all right? Very simple. But in a supply chain, you know that there are many parameters, like, you know, you can pay by installments, or you can have the goods more urgently, or maybe a bit later, you know, different services. So there are a lot of combinations of parameters, which are so sophisticated, which could be better to be done by IA instead of by human, because human will get tired. You know, you need a lot of brain juice to remember all these parameters, you know, and precisely what you want and what they offer, and the next minute they change again and they update again, you know, all these parameters. So better to write a computer program. It's just a simple computer program. There was no neural network at that time. So yes, it's definitely it's happening. It's not just for research. Now, next question: how an auto sweeping machines can be more advanced than AI? Okay, I think you're referring to those auto cleaning bots, those vacuum cleaner, the round little thing that go around the houses. Yeah. I have observed that the first generation is programmed. You just go around by the road that you have programmed. The second generations, now they call it second generation anyway, they have some detection functions. They can avoid obstacles, and they would detect if the floor gets more dirty or dirtier than normal, they will spend more time in cleaning. And also they are quite smart. I don't call it intelligent, but smart in the sense that when they detected the brushes are dirty and their water, you know, they actually contain some little container of water at the back of the little robot anyway, is too dirty, too contaminated, it will go back to the cleaning stations and it will self-clean. So this is what's happening right now with those extra functions, basically detections and making some simple decisions. Yeah, of course, they call it AI anyway. What I see in the next generation would be a holistic connection. That means the cleaning bolt is not working individually. It is connecting to the other sensors. So the other sensors may be able to tell the cleaning bolt, for example, wind speed. They detected the window is open, you know, more dirt have come in, so they should clean here more, you know, that kind of things. And they will also detect about the, actually I got a very interesting so-called consultations with one of the mainland aircon producer. I won't say who, but because actually we didn't end up well anyway. So they are telling me that the next AI generation of aircon, so, you know, aircon is just aircon, just make me cold. How intelligent you want it to be. Then he told me that he had the little infrared. I know every aircon is an infrared. No. The infrared sensor can see how many people are in the house. If they detect more people in the house, they will blow more. And also they will detect and sense about your skin. If they see your skin is dry, that means you're cold, goosebump, they will even turn off. But if they do see your skin got sweat, and also the thermal imagings, they would blow more, you know. So the same logic as if you have a smart home, they detected that your house has more people, maybe a party, more dirty, or people are more active. The cleaning bolt should be, you know, performing harder. So that is the concept. I hope I have answered the questions. Any more? Rita, I don't want to keep talking until 5 by myself.
Well, if you can also select some of the questions that you're interested in.
I'm interested in every question. My God, you pick. Okay, you're the host anyway. 你主場, okay. You ask, I answer.
Well, just randomly go around. Maybe. Well, you just pick anything that you like to answer, I think.
Okay. For those who have posed questions and I haven't answered them, copy and paste them to the email ccfong@umac.mo, ccfong@umac.mo. I type it here. I will answer one by one. Because time is limited here anyway.
Yeah, you can just go to your presentation and then go back to the question again.
All right, sure. Yes. So
yeah.
Okay, let me share the screen and okay. What I have prepared is not really a presentation, but a brainstorming sections, and I like to get everybody involved together. Just now I stopped here, right? About this robot that's supposed to have the intelligence. Now, I think this is a very good graph, but you don't need to read every one of them. I'll just show you. AI, okay, is originated around 1950. So I told you 56, a guy called John McAfee. So he come up with the concept that, well, let's make the machine intelligent, do what human can do. And as you can see that it has many names anyway, even subset of data science. But the aim is to build machines that are capable of thinking like human, the way it think and reason. But nowadays people have sort of broaden the definitions as long as it will perform something cool, right? Even though a very small functions, compared to the version 1, they call it AI. All right, now let's talk a little bit about algorithms. If anyone who used H2O.ai before, you will be familiar that, you know, this is basically an open source platform. You can have access to all the deep learning software.
One reviewer that just told us that, well, for example, auto machine learning, so they think that there is a kind of like black box. So they think that, well, it is not really the thing that we should use for prediction. So what do you think?
Wow,
using the
I
Azure.
absolutely agree. I will come into it very soon. Okay, I'll come into it. I promise.
Okay.
I'll come into it very soon. So we have time all the way until 4:30, right?
Yeah.
Okay, very good. Now, this chart actually is showing something quite significant, especially when we come to the choice of the algorithms. All right. Now, you don't need to know the detail of every single algorithm. You may just know about the best and the worst. So what we have here is the accuracy, the y-axis. So the higher, the better. However, in here, the x-axis is a training time. All right. That means towards the right hand is bad. It takes a long time to train and to teach. So some famous one, as you can see, the best one over here is the one in orange color. This is actually gradient boosting. Gradient boosting is not something new anyway, but it could be quite strong. However, it is not as strong as the blue line, because you can see the blue line is deep learning. It can even go, in fact, deep learning is the highest. But time it take here is about average. All right, so you can't say deep learning is too slow, but it is never too fast anyway. So if you want deep learning to perform at a very high accuracy, you have to pay something like $4 out of $10. Okay, in the analogy. However, there are some cheaper ones. The purple one here is quick, and the red one here is also quick. ENS simply means ensemble. Ensemble means you put a bunch of algorithms, and then you let them run, and then you pick the best one. Yeah. So the purple is quite classical, is naive based, is by probability kind of learning. So this chart actually shows us different algorithm you choose would have a totally different outcome. Okay. Yeah. In other words, it's very sense if you have a real-time applications and you want something very accurate, no choice. I mean, you have to wait. So this is the theme of the talk today here. Fast AI and data stream mining. These are two contradicting forces. Yeah. Like if you want a good meal, you have to go to a 5-star restaurant. You have to wait for the chef to cook for you. If you want something fast, you can just grab a burger from McDonald's restaurant, all right? But you don't expect it will be too delicious. So this is always a strong demand. It's a bit greedy anyway. You want both fast and accurate. Just like you want to buy a car that is fast, luxury, and cheap. You buy a property house that is, good, luxury, and cheap. This is not easy. All right. Now, the next two graph I show you is quite interesting. It shows about the commercial values or the business values. It actually declines. Okay. Whatever happens, all right. Let's say you have an idea, you have a concept, you have to roll out a new product, the value will drop. Yeah. Okay, the value will drop. So the sooner you roll out the product, the sooner you make a decisions, the better place you will be. Common sense. So what we will see here is with the data latencies, collections. And here, a main part of it is actually the analysis latencies. So if you have a deep learning, you just keep on running and running. I tried before. Even I tried on a normal laptop, run deep learning to recognize hand digits. You write 1, 2, 3, 4, 5, 6 to recognize just this. It took about a whole night to run, to just get one result. So this is what's happening here with the latencies. Yeah. And for the critical applications, like if you send a drone to look for survivor, let's say we have an earthquake or some disaster or maybe a building collapse, we have this so-called a golden hour for rescue. So the longer it takes, all right, the higher the reach, the bigger the damage that you will get. So it shows that once again, if you have a high-speed sensor, which is good, you can cut down the data latencies. You have a good infrastructure, 5G, whatever communication, that's very good. But the analysis part, you cannot escape. All right, you still have the neural, you still take time and so on. And this is what exactly I'm going to move on to the last few slides. I talk about the 3 things that are happening in the future regarding this kind of fast AI. Now, for those who are familiar with data mining, you should know that you just build a model based on the past experience. So we have the past database archive, and we extract the features, and then we fit them in. I just like to give a scenario of you want to teach a neural network that is exactly how you teach a young child. All right, if you want to teach them a young child to speak French, You every day read them French. You want to speak Mandarin, 普通话, then every day you give them books and then teach. Once you think that you have teach them well, they are ready to go for a test. So it's the same thing here. They have a training and they also have the testing. So once the training is mature, we put it into tests, closed book exam, for example. They have a list of questions and they try to recall what they have learned, and then they give you the result, and also you measure the performance. So this part here is the traditional data mining. Okay, very simple. Now, data stream mining is slightly different because we don't have an archive of data. The data come in streams. How big is a stream? I can't tell.
So IoT kind of data, right?
Yeah, it could be news feed, it could be stock market feed, it could be whatever EEG, ECG, whatever sensor, or even video, CCTV. If you want to do video analytics, you can have access to the past 1 day, 7 days, but potentially these data are infinite, they're unbound. Okay, there's infinite. So what do? We need something called incremental learner. All right, I won't go into the theory and the mathematics until Rita invite me again for a workshop. All right, I'll teach you from the mathematics and how to do it in programming. But now I just want to show you the differences. In here, we have something incremental update. That means the data come in by window by window. So each time a window of data come in, it learns an update and then it will forget about it. After that, come update, forget about it, come update, forget about it. So this is fundamentally how the two differ. Now, decision tree. On the left-hand side here, this is how decision tree look like. So when a test value come in, you make a decision, branch left, branch right. But before that, how do you get a decision tree? You have to got it from the existing, what we call historical data. All right, now this is the traditional decision tree. That means you assume you have all the data available. So what we do is, just like SVM support vector machines, we want to do the partitions. So each time when you do a partitions, you chop the data, you spit out one test, conditional tests. Let's test whether Professor Rita is a kind person. Well, first test, did she ever punish any student? No, yes, and then if ever she never punished any student, did she punish any colleague, any friend, wow. Did she do exercises? Did she do donations? Did she go and pray, for example? So it's a matter of partitioning the data. And of course, it's not just one Rita anyway. This is maybe for terrorists, for fraud detection. So you have many accumulated instances, historical record. All right, so this is the traditional way of building up a decision tree. So when we talk about training a model, okay, what I mean is, based on the existing data, like here, red and blue, we have a two-class, a binary classification, means good or bad, yes or no, fraud or not fraud. All right, you can have more classes if you want, but I just give you one simple example. You make the partitions. It's called partition based on the full set of record. Now think about it. If your data is not static, it keeps updating, new data keeps updating all the time, what do? You have to repeat these processes. Am I right? You have to repeat these segmentations, these processes. You have to repeatedly rebuild the decision tree all the time. Assumed you build the decision tree using maybe 5 minutes based on 50 gigabyte of data for one decision tree, 5 minutes. What if you have big data, from 5 gigabyte to 500 gigabyte, 5 terabyte, petabyte, or whatever. So eventually you will come to a point that it will take you forever the time to build a decision tree. Of course, you may say, why need to build a decision tree? Just use an old one, okay? But the old decision tree that was built based on the existing data may not be valid anymore, especially in a very dynamic situations like Hong Kong, for example. I mean, the pandemic anyway, it's very dynamic. So in very dynamic situations, real-time situations, these unfortunately, this still being applied and many people still using it anyway. I don't want to offend any factories or whatever. They're still using this traditional way. But there is a new way, alternative way. That means data stream. So for data stream is bottom up. Bottom up means in this small example here, you can see that data stream keep on coming. It will just make a very small decision to begin with. So we call it a single node. So this single node will keep observing. So if what's this? It's web visit, right? So if a web visit less than 10, there's a new guy. If a web visit more than 10 times, is a regular customer. And as the data come in, we will keep track about the nature of the data. So if there's something else, for example, the data actually contains not just about old visitor and new visitor, it has also contain about promotions. So it will automatically infer another level of decisions based on the complexity of the data. So as you can imagine, if the data has more and more complexity, it will have more and more decision nodes. That's how it's built anyway. We call it the ground up level. So we build it from ground zero with a single node. And then it will sort of build up in this way. And then it will update by itself, by some statistics. So this is a bottom-up approach. Now, what is the implications? The implication is, I call it the usefulness. Usefulness. I simulate, actually it's my PhD student who simulate this. The Y size is the accuracy. The X size is the data. So assuming we have the data that keep on expanding, right? You can see that the model that we built in the beginnings quickly dropped the accuracy because we only built it with 5,000 data. But here come, 3,000 data. Here coming another 3,000 data, another 3,000, another 3,000. Just like a small child, if you just teach them using just 3 chapters, all right. But in the test, there's a lot of new chapters he never see before. So don't expect the child can score 100%. So the performance actually drop. Until this point of time, you stop a while. You let the child to be trained again, to learn all those data again. All right. Skip to 15,000. So have to learn all this data and then it will boost up. But as a new data comes in, it drops again. It pause, learn again, and then drop again. Learn again, it goes up and then drop again. So you can see that it roughly forms an exponential curve because everything has a limit anyway. You cannot, really get 100%.
Simon, which kind of software is that for like this kind of training?
Decision tree, the most classical one.
Oh, okay.
Yeah, C4.5 and using Webka, very small Java program.
Okay.
Yeah, so let's take a look at data stream mining. Data stream mining, it works like this. We call it a grace period. In the grace period, it drops and then it will progressively go up and up and up. All right, so this is, I'm not saying that data stream mining is superior to traditional. No, it may not even be better than that, but it's faster and it can approximately equal to, or I won't say better, or as good as the traditional. For example, if I use deep learning, I can achieve 99%, but it takes me 3 days and 3 nights to run. Okay, but I get 99%, I'm happy, right? However, I use data stream mining, I may just get 95%, but I only need to spend 1 minute. You see what I mean? It's a compromise. So you will get less accuracy, approximate accuracy, but it's much quicker. Because of the fundamental design of the algorithm. So that is the kind of things that we are dealing with. Now, I won't go into detail, but I just give you some scenarios of where these kind of fast AI or data stream minings can come into. We got half an hour left, but I really want to spend time chit-chatting with you. Now, nowadays, okay, before this is actually quite old. This is at least 5 or 6 years old. When we talk about smart city, yeah, we have layers. We have the IoT at the bottom, and then we have the middleware, and then we have the application server, and then you can do all the wonderful things on the top. All right, it can sell very well to anybody. Okay, but where's the AI part? Oh, who cares anyway? But okay, now we care because the smart city also evolved. Okay, this is something I have seen at least 10 years ago. Smart city. Nowadays, they are talking about edge or fog. Edge computing or fog computing, because I mean, just like any .com, if you inflate too much, you over exaggerate too much, you have a bubble and it will burst. So I believe, without offense to anybody or any project, people and government have already invested a lot into the smart city projects. Now, when they have really operated, they will encounter bottleneck. the most significant bottleneck is, imagine if all the sensors who take all the data, put into the cloud, all right, there will be a bottleneck. And therefore, Cisco is very smart in both business and in technology. Cisco actually predicted this will happen. So they come up with this concept called fog. Fog means they push the data analytic and their process to the devices or to the edge of the network as far as possible in order to relieve the workload at the cloud. Make sense? Okay. So what I mean here is, if you compare those big guys in the cloud computing, which is very powerful computers with many gigabytes of RAM, with a little, I'll show you a real thing.
The camera.
Okay, camera, it has this antenna here, so you can connect to Wi-Fi, whatever, and it can move, there's a mechanical part. But if you open it, right, it's nothing but just a small little microchip. Okay, yeah. So we're talking about not a laptop, not even a laptop, not even an iPhone. Even the iPhone will have a much powerful CPU, into this. But of course, they can make it as powerful as iPhone, but they want to sell it at only 200 Hong Kong dollars. What do we expect? So they want to have something that can do the job and cheap and affordable. All right. So I think the algorithm is one part. So instead of using very sophisticated algorithms at the edge level, they want to use something lightweight, online analytic, edge analytic, whatever name that they want to call it. So this is the full picture that I have here. Now I just talk about the Internet of Things. That can be a camera, can be a sensor. They would feed in a lot of data into the cloud, and the cloud have a big data, and we can do this big data analytics. Now I don't really call it AI because analytics simply means multiplications, divisions, finding the average, statistics. They're good enough for a dashboard. If you want to monitor something, you can program a threshold. If you go higher, then something is abnormal, that kind of things. But this is not really machine learning. When we talk about a fog, that means the device, we call something streaming analytics. And once again, analytic is just good for statistics calculations. Now, the progress of the technology is so amazing. Even the little chip that I show you, the prices of programming some AI into a chip is getting cheaper every day, getting more and more affordable every day. And I agree with some of you who told me it's a black box, Rita, right? It's a black box. I believe, yeah, of course, a black box. How can it be a white box? This is intellectual property. Okay, it can't be open source. It has to be a commercial secret. All right. So, in the R&D team, this is what they do anyway. They would so-called program the formulas. They program the mathematical models into the chip, in the chip level. But after all, once again, is cost and benefits. You do not want to use a very expensive chip, and you do not want to spend too much resources into programming the AI part into it. You just program something that is just good enough. This is what's happening right now. But I do see that in the futures, even the R&D courses will drop. We have many good PhD graduates. They are able to do the programming job and so forth. So they will program something like this. This is what I want to show you. This is data mining techniques. These are the so-called 7 most popular functions by data mining techniques. I just quickly go through each one of them. Classification. That means you can train a model to recognize something normal, abnormal, good, and bad. Clusterings is finding the hotspots of certain data. Regression means like stock market, you base on a past history, you try to make a forecast. So regression is basically forecastings. Outlier, it's not outer, it's a typo anyway. Outlier means you are finding some very unusual numbers, either it's very high or very low in your data. Sequential pattern means the cause and effect. That means an event that happened and followed by what event and so on. It's cause and effect. predictions. You know what prediction is? You usually predict a number, predict a value, which is different for classifications. Classification, you have to predefine the label, good, bad, boy or girl, that kind of thing, high, low. But predictions can be anything. The last one is association rules. That means there are patterns which two or more events that happen together. Now, data mining. Okay, I can talk for half a year, but in here, I think I just gave a brief understanding. And I'm going to show you in the next few projects about where and what kind of data minings you think, as AI can put into the projects. Okay, I start with a smart city. Okay, because it's very hot now. And for smart city, basically, we have the sensors. We want to know what, how, when, and why everyone or everything is working or not working, right? So this is smart city. Now, why you want to know? Okay, it's because we want to make decisions, or maybe the government want to make decisions. Whatever decisions, and then real-time interactions, providing a service, or it could be like surveillance, security, for example. They want to detect anything suspicious, potentially got riot, that sort of things. And then optimizations, planning in the long run for better use of resources. So we have this kind of general pretext, context. And one of the projects I have with in Beijing anyway, North China University of Technologies, they have this IoT electricity utilization forecasting using IoT platform based on real-time analysis. So this is real. Actually, they actually test it in a hotel. They have this intelligent socket that measure about the energy consumptions. It can control the device as well. Now, it will work for hotel, basically hotel, public buildings, school, and so forth, because Beijing, the weather, it could be very cold, and you need to turn on the heater, for example, and the heater won't be just become hot as soon as you turn it on. They will have some sort of timing. So they want to find the best timing patterns in such a way that the people would feel comfortable. They won't feel too cold or too hot, but at the same time, they would save energy. Like, for example, if they know that a meeting is going to end 15 minutes before that, they may turn off the heater, because after that, they predict there will be nobody. All right, something like this. So in that case, we have a number of functions, which we call it the AI. We want to find the hotspot. That's why we have clusterings. And we make forecasts, regressions. Outlier is for those who black out, draw too much electricity and then black out. We want to find them out. And also we want to predict when a blackout may happen, because a blackout may be it's due to a single fault on a single device, or maybe multiple instances. For example, especially factories. If suddenly too many factories activate, at abnormal time, usually daytime and nighttime, the rates are different, the demands are different, but they want to find out what actually happened to lead to certain events. So all these are data mining. And this kind of data mining, for this scenario, is not too urgent, because it's about energy saving anyway. If you don't do it immediately, there's no harm anyway. It won't cause any death and life and death. But I will show you more examples. This one here, with Laura Brough University in UK, and also SUSTech in Shenzhen. We have something called water consumption, because the UK team, they have a contract with the Greek government in Greece. I think those years they're having drought, they have no water. So they want to match the demand and supply of the water as accurate as possible. So that's why they put before you match, you must know about the water consumption pattern, all right? And then you also know about the limit of the supply. So these are all the gadgets, these are the low-level things, they have no intelligence anyway. So it's basically a wireless sensor network. They call it IoT network anyway. This is generation one. The basic functions that you can have the app on your phone to keep track of the water that you have consumed, your washing machines or your tap, and different locations. But at the back end, from the view of a government, they want to know about the consumption pattern. as refined as, of course, they know the total consumptions, but they want to break it down into different suburbs, even different street, different household, so they can better match the distributions of the water, which is very limited. So this is a kind of project where the data mining or the so-called AI come into it. Now, we haven't really go into the fast AI, okay? Okay, because I know it's quite bad. If you run out of water, it's not enough, but it's not that critical.
Yeah.
Yeah, maybe they cannot bathe, all right? This is critical. So the SAM team, they also got funded by the UK, the fire, I think the agency, the fire bridge agencies. They called it the fire net, the safety net. So they put sensor on the firemen, on the fire engines, connect them up, and we have an infrastructure that we have the information about the site that is burning, because any wrong decision means loss of life for the firemen and loss of life for those we try to rescue. So this is critical, this is urgent. We cannot wait 3 days, 3 nights for a deep learning to come up with decisions. All right, so this is quite interesting.
So for the Internet of Breath, because the Internet of Things that I know very well, but I don't know what is Internet of Breath.
Okay, we breathe, all right? We breathe in oxygen and we breathe out CO2. So Internet of Breath basically is a sensor. We call it a CO2 sensor.
Oh,
so,
okay, I see.
Yeah, because that project is already funded by UK. They've been, doing it for over 10 years.
Yeah.
Simon Fong come in, I cannot just repeat the same thing.
Yeah.
So I enhance it to version 1.5. The firemen, right? They have this gas sensor to detect basically toxic gases.
Yeah.
And also the temperature, and so on. So before they feel too hot, right? They actually would know it in advance. And they also have the pattern, because they can predict if the rise of temperature, if maybe 60 seconds later, it may reach a critical level.
Sorry
so
for
they
my interruption. And how easy is that for doing this kind of project? Because most likely that you will not experience a fire, right?
Well, that project was actually initiated by the fire brigade, and they outsourced, the fire brigade.
Okay.
Yeah, it's a government project. In other words, if we sell an IT company, you want to sell, no one will buy it anyway.
Yeah, right. I'm just wondering, probably elderly house that is useful because they may have forgotten everything and then forgot to turn off the fire whatsoever. But for ordinary people that they do not have any intention to buy it.
Because they don't see the value, maybe.
Yeah.
Yeah. I will come into the next case, which is about what you have just mentioned, the elderly home and so on. It's very, very interesting. So I put an extra thing here, the CO2, because CO2 can perform 2 functions. One is you can tell about, because actually the fire, before the fire kill you, is actually the smoke that kill people, right? So they can actually measure about the CO2. The higher the concentration, the worse the scenario is. And the second function is it actually can tell about occupancy, how many human in a room. Because if you know about the background CO2 level, and you have more and more people come into the room, and assumed you don't open all the windows, right? You are an aircon, enclosed environment indoor. We can quite accurately predict using machine learning how many people are there. All right, so it shows in this chart.
That would be useful for student hall then.
Yes, that's right. That's right. And that's why exactly in the afternoon classes, people were sleepy. Okay, you cannot blame them because they eat a very heavy lunch. Yes, partly because of the lunch effect, but also because of the oxygen level. All right, because in the afternoon, the CO2 level is relatively high. And that's why in meetings, we need a coffee at about 3 p.m. To refresh ourselves, yes. So in this chart, as you can see, that the x-axis is the concentration level. So the higher the concentration, the higher the chances there are many people. And blue one means is zero occupancy or a single person. So we have tested and it's actually quite accurate in our lab. Anyway, now go back to this scenario here. If we have the normal sensors, the fireman will know about the situation, about the fire, the burning. But if we have the CO2 sensor as well, we would know about just before the fire break out, potentially which room or which sections may have people there. Okay, so that the fireman doesn't have to, bang open door one by one, which takes up their time anyway. So they can go directly to the rooms which was recorded to have people before. So
how expensive
accurate.
is this kind of the sensor to be built for CO2 sensor?
Oh, very cheap. If you buy from Taobao, once again, right? If you buy from Taobao as a retail, it costs about, I think, 10 renminbi.
That's very cheap then.
It's very cheap. If you go Ali and negotiate, you buy 1,000, you can get it even cheaper. Yeah, and you don't need very high accuracy anyway, because for any hotel room, I think they have the fires a sprinkle that has a little chemical there. So if it's too hot, it will break and then the water come down, right? Now, that has a problem because you must have the burning object hot enough to melt the fuse, and it will detect an alarm, right? So by the time already big fire, right? But CO2 is different. They can detect a sudden rise of CO2. Okay, even though now is what people burn this whatever off for it, or even smoking. When it detects a sudden rise of CO2, they would know. They would know about it, before the fire alarm go off. So it's an early detection.
Yeah.
It's just a side benefit anyway. Yeah. Now, for this kind of scenario, what do you think the AI or what functions do you think it will come in?
I think it's just like IoT would be sufficient. No need to have like sort of like AI. Because it's just have all the things communicate with one another and then send the signal, that's it. Right?
That's right, yeah. For the basic ones, yes, I would say there are two levels of functions. For the basic ones, detection. Detection, we don't need AI,
Yeah.
Just like what you say, too high the fire, too much CO2, wow, something wrong. Okay. Yeah, you don't need AI. But AI comes into basically predicting. Predict what? Oh, gee, I forgot. Predict what?
Predict the fire that will happen by the time there are too high CO2 level.
But yes. It will forecast. It will predict based on the burning pattern, because we are not focusing on a single instance. We look at the development of the fire. Australian bushfire, right? It actually built up. So when they build up to certain momentum, it's 100 km per hour. I just watched a video clip, very scary. When they come, it's no chance to run. Even if you have a car, got 100 km per hour. I mean, in a forest area, So if you have the forewarning, I think they will be good. So for safety, I think it's more to do with the forewarning. Same for manufacturing, like accident doesn't happen suddenly. If you watch this movie Final Destination, you know what I mean, right? Every accident is a series of incidents that actually link up together. Remember, 死神來了, right? Final Destinations.
Yeah.
Talk about how different people die, all right? So it's actually a series of things that happen to lead to a the final one. So I think the sensor will help about measuring the aging, potential cracks, or any health status of the material and so forth. You need to get all the data in, formulate a model, a risk model, or a potential accident model, and then you keep monitor from behind. If any pattern that is progressing, similar to the model that would lead to an accident, I think this is where AI would come in.
So there's a kind of like prediction simulation, but then is it accurate? I just wonder. This kind of the experiment has been done, right? So
well, yes. Because building relate to about safety. I think in New York they have simulated about a subway. In case of fire, what are the best escape route? Because it's so complex. The structure is complex, and then the traffic is complex. That depends on how many people are there, in different locations. So they want to use AI, which is basically some calculations, to formulate the best escape route. And it can even predict the chances of casualties, chances of people who escape, alive.
Shortest route. Oh yes, this one can be done by AI. I think so.
Some sort of computation. I won't say AI in the sense of self-learning, or asking about who am I, that kind of things. All right, but at least AI. It will have the computations that can make a predictions, and they can not only make a prediction, but they can score about how probable that prediction is. That's why probability machine learning is one of my favorite anyway. Who doesn't just give you about like, for example, when I'm going to die, but I want to know why the prediction coming this way and what can I do about it, you know? Yeah. So let's move on. We can have another separate workshop just to talk about this topic.
Right.
Okay. Now go back to the mushrooms in Thailand. You know, Thailand come into my mind best food rice. In Hong Kong, I think most of the quality rice come from Thailand. So they care very much about the agriculture. I think we have seen this before, the mushroom thing. And if you expand further, right, this is actually the IoT farming. They call it the smart farming. First of all, you need all the sensor, whether they are mushrooms or whatever shape, doesn't matter anyway, because this is the connectivity. Now, once you have the connectivity, you have all the data, you can build a models in here, you can do the classification. Let me just go through this one by one quickly. You can classify whether your farming conditions is good or bad. All right. And also you can do clustering in case of too much rain, too much water, pollution. You can identify where are the hotspots, or the, you know, you can use different color to represent it. Regression basically is forecastings, but these forecastings, in my opinion, it should not be a closed system. It should be an ecosystem, because farming is very much related to the weather, the water quality, and so forth. So, I mean, it doesn't make sense if you just put a few sensors onto the soil and then you think magic will happen. This should be a holistic approach. You should connect it with the weather data, you know, the soil conditions, the water conditions, and even the agriculture practice, the nutrition, the fertilizer you apply. All this data put together, you can make forecasts. Outlier is to find out something extraordinarily good or extraordinarily bad. And sequential patterns, this I'm not quite sure, but I believe things will happen, you know, cause and effect is like, for example, if you know, butterfly effect, right? Let's say you have a faulty tap somewhere, that faulty tap will suddenly flood one place, and then the flooding will cause another problem, and eventually a big problem. So hopefully IoT plus the kind of data mining could pick out this kind of sequential pattern, which is we call it another causality or causality, 因果關係 in Cantonese, you know, cause and effect. Of course, it makes predictions, and also it makes association rule. Association rule means things that happen at the same time. Like, for example, some cows, from what I observed, because I have some project before, not with Thailand, but with Cicero actually, as a consultant. And Cicero, Tasmania, they measure about the environment, similar to this one here. Just for milk, cow milk, they found out that when the cows are happy, the milk is better. The quality, the protein are better. Now, how to make them happy?
So how to measure whether or not that they are happy?
Okay, we cannot measure the brain level, you know, how high they are, right? But when the cows are happy, they would be more social. That means they would like to stay together, closely together, under a bright. They actually correlated with the moon pattern, which is something amazing, which is published in the Nature anyway. So when you have a full moon, when they have a full moon,
just let me know about anything I can contribute to nature.
Yeah, exactly. Yes. So when the cows are happy under the full moon, they would tend to stay together. You know, when they are depressed, they will be isolated. So this is how they measure them. Yeah. So we want to find the association. What make the cow stay together? You know, when they stay together, that means, well, you know, they do happy things. So they psychologically will be happy, and they will make more milk. So association means we will see what events actually associate to certain characteristics of the ecosystem. So this is where the AI comes in. Now, last one here by Lakehead University. We are a bit ambitious because we first thought of we can monitor about the campus, all right, to avoid accident to happen. And also we want to check about the traffic flow. But checking traffic flow doesn't work because in Canada, there's basically no traffic jam. Yeah, I mean, unlike Hong Kong and Macau here is so highly densely populated, there there's no traffic, there's no car anyway, basically. Most of the time it's no car. So we want to check about anomaly detection. That means if you imagine, right, from the drone air view, you detected one walking student walking at a normal speed. Suddenly another one running very fast towards the student, bang. And then this student doesn't move anymore. And then this bad guy suddenly run away towards the forest. What does it mean? It means some violence may have happened. And then we can dispatch the rescue team. So that was our original idea. But it doesn't work as well because it was so safe. There was no accident. So the whole project was sort of converted into, I think you just mentioned, Rita, we have sort of narrowed down from the whole campus into a street or even into an old folks home, which is, we call it focused monitoring. Like, for example, the smart lamp post with the CCTV, we want to detect any suspicious patterns. I don't want to talk about Hong Kong, but in Africa, before any riot, riot is really real riot. The police actually use real bullet and kill the student, and the student will set fire into the university. Now, before that happens, there are some signs. They started with a few guys, singing, dancing, and more and more people from the village, will come together as an event. And when the people are more and more agitated, you can tell by the movement, more and more crazy, right? They will start doing the violent things. All right, so there is a pattern of this kind of riot. Now, this is, I think it's Rita's favorite. We use video analytics. We use what we call the depth camera, depth, D-E-P-T-H, the depth camera, like those Microsoft camera, to recognize about what people are actually doing. So they have implication of security monitoring, smart homes, sports healthcare, or monitoring elders, and so forth. So we have been doing this actually in the past 10 years or so with the Canadian team. One very popular one is called fall detection. So someone just slip and fall down in the IC row. But in old folks' homes, it means an elder may have accidentally fall down, even in the hospital. This is something that they really want to know. So we get these video images. It could be, that depends anyway, but because for security, you need a face anyway. You need to actually identify who they are. But for old folks' home, I mean, come on, privacy, all right? You don't want to know so detail, but you may want to know about the outline, like those matchstick figures here. So you may just want to know about whether they're dancing or they're fighting, they're sitting, they're running, they're standing, they're sleeping, and then we can have another level of program to check whether these activities are normal or not. Like, for example, if you're cooking in the kitchens, lunchtime, dinner time is normal, but if you're cooking about 4 or 5 a.m. is abnormal. And if you're lying down in your bed for 6 hours, it's normal. Even 16 hours is normal, all right? But if you're lying down on your toilet, all right, even 5 minutes is abnormal. That means you may have fainted. So we can use this data mining technique to classify actually normal, abnormal, and outlier. Outlier means something extraordinary, like someone who moved too fast or not moving for too long, for examples. Because the same logic actually can apply to whatever IoT. There can be remote sensing, like CCTV is remote sensing anyway, or wearable. Wearable means as a wristband, or maybe it's something called accelerated meter. It's built in your smartphone anyway. It would tell you the XYZ locations. Now, this is the kind of Microsoft Kinect camera I was talking about. They do not see the full face anyway. They only see the shadow. And from the shadow, the movement, these basically data streams. From the movement, we will train a model, just like how you train a kid to see, okay, this guy is dancing, this guy is violent, this is not, normal, abnormal, and so forth. So I spent a whole summer holiday with KMUTT, the data team, and we artificially created all these activities for training the model because we want to find the best algorithm the so-called fast AI. It take in this form anyway. We can have another workshop. I will show you how actually we can build a models, training, testings, deep learning, how to do this. But just to give you some idea, just to base on XYZ. Okay, for example, you put your sensor in your pocket, XYZ, and you're trying to let the computer to guess what you are doing, standing, walking, going up, downstairs, and so on. We have a data stream that goes like this, and potentially is infinite. All right, and I can show you using the traditional and then the incremental, and you will see the difference. Something like this. It's just illustrations. So if you visualize out the sensor data, this is how it look like. XYZ, that's the simplest, but the KeyNet is more complicated. It could be hundreds or thousands of variables, but in here it's only 3 variables. So based on 3 variables, you can easily train a neural network XYZ, and then to predict what activity it is. All right, so that is a basic logic here. And the implication is you can build a model, not truly AI, but you can still call it AI anyway. It can make a decision to tell you whether this is, normal or abnormal, dangerous or okay. Okay, I would want to move to, because now it's 4:30, I want to leave some time for Q&A. Is it okay? We sort of overrun it for another 10 minutes. Okay, so I skip this kind of, what we call burning brain kind of things. You watch Telnet, you burn your brain all the way. Christopher Nolan, Telnet. Okay, so I skip all this, and I want to go to these few slides, which will conclude this webinar. Now, I see that there are 3 possible futures. Okay.
Yeah.
We are moving forward anyway. In the time we are moving forward, just to let you know that. Okay.
Theme type of the like moving
That's
forward.
right. we are linear. The clock is still ticking anyway, so you don't see bullet coming into the gun, all right? We have to reverse the entropy. Okay. Now, from now to the future, I will see the explainable AI. I think Rita just mentioned, things that could be explained, because what we have today is quite frustrating. Well, like in this simple example here, you train and train and train a neural network, it tells you something. Okay, this is a cat, but it won't tell you why it's a cat. All right, but you think about some implications, like you see a doctor, or I see a doctor tell me, sorry, you're going to die next year. Why? I want to know why, so that I won't die next year. Am I right? Even though I accept my fate, okay, I'm going to die anyway. It doesn't matter next year or tomorrow, but at least I know what are the chances and what cause this event will happen. So this is why it's so important here, like this example. We have an additional part. We call it an explainable model. What you see is a network. That means any eventual event, any result, they must be caused by some factors, one by one. All right. So assume we cannot reverse time. So at least we would know what will cause what to cause what, and this could be predicted. In this example, well, this is a cat because it's a viscid and it has claws. All right. So that's why it's classified in the cat. And this I predicted to be the future, but back to about 3 years ago, I have a master student. Now she's my PhD student. She's called Li Tangyu. She worked on a master thesis just based on this topic. We call it White Box. We published in the IEEE magazine. The date is October 2019. Okay, I'm not proud about the result, but I'm proud about that. My ability to forecast 2019 October. That means we already started working on it in the beginning of last year. White box will be the future. Deep learning, people will feel frustrated about it. We want to explain. So we just published a paper just last month here. We apply this with a real case of cancer detections. All right, because nowadays deep learning is so powerful. You can scan through whatever, X-ray, CT scan, and derive an answer. But we want to know why it come to this answer. So we had make this progress. This paper basically is her whole master thesis anyway. Yeah, so just to give you one example here. Explainable AI, on top of the diagram, this is what we have. Just like IoT, you have the sensor, we have the cloud, we have the connectivity. So similarly for hospital, they have a central archive with all the X-rays, all the consultation records from, it doesn't matter you visit this hospital or that one, all will be consolidated somewhere. you may think about what's next. What's next is, below is the software part. The software part can do the wonderful thing because you can program AI. You can add some AI deep learning to help scanning to identify more precisely where the problem part is. And for consultations, we need to provide some kind of answer and explanations on about how the doctor come into this conclusion. I think we have encountered all these, like you see a doctor, you ask them, what's the chance of success of the surgery? The doctor may tell you, well, about 30%. Why? He cannot tell you. You know what I mean? Okay, yeah. So just like my mom, she passed away. We will offer, she only got 20% survival, but we want to know why. The doctor can't tell. So she decided not to do it, and then she died. Okay, but to me, I think that she should still try. Why she have the 20% and why she have the 80% failure, so that we can make a more, I won't say better, you know, a more scientific decisions. But you know, a normal human is say that okay, only 20%, just die, you know. Anyway, so this is why exactly I was inspired to do this project. I want decision to be explainable. Like this one here, you look at this network, this is actually a Bayesian network. Eventually the center one here is a result. It's about, I think, liver cancer. So for liver cancer, there are multiple factors. Those green dots are the factors, like you drink too much alcohol, you too late sleep, or maybe didn't take enough vitamin, lack of exercises, and then step by step, maybe the liver cell hardened and so forth. So things won't just happen magically over one night. You can see why this decision was derived and what are the factors involved. And on the right side, each one of these will have the probabilities. So I think this is the future. And you can see here, high accuracy by highly sophisticated, like deep learning, may not take a favor. All right. Rather, if you need to have a very quick decision, you may want to try data stream mining, but the model is supposed to be explainable. Okay, so this is one of the three that I would foresee. Now, the second one. Actually, the second one is none of our profession, my profession at least, none of my profession, but it is my business, your business, because I'm using an iPhone. And you know that is a very hot battle now in the mobile phone market. They talk about what? The microchip. And this is what exactly US is doing. They want to cut the technologies to transfer to China about going into very, very tiny nano. So this is the latest one, A14, 5 nano. Right, 5 nano. I think China, they are managed to do it with 40 nano, which is quite scientific. The smaller the size means you can have more transistors built into the chip, and therefore you can have more powerful functions. Like here, you will have a faster neural engines. So what I believe is, in the future, we are not running on a mainframe. We are not running things on a laptop or you know, or even a desktop. It will be running on a single chip, and that is the ideal scenario for fog computing. You know, for a little device like this one, or the one I'm holding, it may have a microchip that has the AI built into it. It can do the classification, predictions, recognitions, and so on, all in one chip. So this is the second trend I foresee will be coming in. Now, this is just some example about the new feature of iPhone. You can use gesture, okay, to remotely control something. So that involves basically about the AI part, which can recognize, you know, the example I gave you, the XYZ, the free data that can, you know, learn by a model and make a prediction about what the activity is. But hand gesture has more combination anyway. It's not just XYZ. So they must have their proprietary technologies. I think hundreds and hundreds of data that being perceived by the camera, even IR camera. And the little chip, they call it the neural engine here to make a decision. So this is what's going to happen. The picture below is doing the picture enhancement anyway. So if you take a picture of poor quality, it will automatically enhance it for you. All this will be powered by a very powerful microchip. So that is the second thing. Now, the second thing also have the another implications. Just forget about my mobile phones for a while. Drones. any machines that fly, that move, that crawl, that even dive in the water, submarine, for example, that kind of boat, you cannot connect it with a computer to run a program, with a CPU, because they are so small. And they're so mobile. And they may have to be robust. That means waterproof, fireproof, crash-proof, or whatever, acid-proof, all right? So they have to have a microchip that contain the AI to fulfill this speed and accuracy requirement. Like the example I bring up earlier, point cloud by the leader. So the point cloud data is so huge, and the experiment I'm doing right now is I just want the machine to tell me whether this is a tree or a human pedestrian or a rock or a bush. It's just as simple as that. Okay, so this is kind of things that we have been doing, and I foresee that will be the future about fast AI. This is just another example anyway, because it's so dynamic anyway. It's not a stationary camera. It's not a smart lamp pole. Okay, it's high flying machines. As they fly along, you have to detect multiple targets together. So think of the computing requirement. Think about the data that it collect, and think about the data analytics. Remember the chart I showed you? Every latencies will lead to about eventually how long it would take for the device to make a decision. Okay, so we want this, for example, if for military, right, we wanted to make a quick decision before the eagle identify and shoot down. Am I right? If it take 1 minute to make a decision, you already got shoot down. So we have to be very fast, in terms of AI. So that is the second trend I observe. Now the third trend, of course, 5G. 5G will give us a lot of bandwidth, very rich data. Point cloud, no problem, because supposedly 5G, you can download 3 movies in 1 second, 10 gigabit per second anyway. And about 2030, there's another 10 years from now, 300 movies in 1 second. Okay, so you can think about the richness of the data. So the bottleneck now actually is the algorithm, the so-called AI. We have to burn into a chip. They have to be light, it have to be good, and it have to be fast. And this is the end of my talk. And lastly, I show a picture, something I wish I could have access to. I got a few millions grant a few years ago, but the US company didn't want to sell it to me, a quantum computer. Okay, so for those of you, especially fresh PhD, believe me, if you choose quantum computing today, 5 years later, your salary will be one of the highest in the world.
Really?
Okay. Yes, my prediction. You can record that anyway.
Okay. Sure.
Thank you, Rita. This is the end.
Thank you, Simon. Yeah. Thank you very much. So we will just end up here. For the questions, maybe you just suggest it later on. So thank you very much, because we are a lot overrun, and then we'll just end up here. So thanks very much. Thank you, everyone. So we have got another seminar tomorrow. Thank you.
Okay, stay in touch. Bye-bye.
Bye-bye. Bye-bye.